Well, welcome. Hey, on behalf of Open Source Six Sigma, we welcome you to this Lean Six Sigma Black Belt training course. My name is Dave Dupree, and I'm going to be your facilitator through the various sections we're going to cover here in the course. I've got close to 4 decades of experience as a Master Black Belt and was fortunate enough to be part of Six Sigma as it became Six Sigma at Motorola, and then through to going outside of Motorola to other companies, and then companies like yourself, where we're going to try to deploy the Lean Six Sigma methodology. Right, so the course has been designed to build your knowledge, capabilities, competencies, so that you can help improve the performance of processes. And then subsequently, right, as your processes improve, the performance at the business improves as well. So whether you call it top down or bottom up, making every process better will make the business performance that much better as well. The course is process-centric, and you'll see that as we go. We always talk about process improvement and data-driven decisions. So you'll look at how we improve processes using the Lean Six Sigma methodology with a little process and project management and change managements thrown in as well. So by taking the course, we think that you'll have a very well-rounded and firm grasp on the tools and methodology. And right, I'm hoping that through my experience and some of the examples that we show you here, that it'll be very effective in your learning and ability to apply this in your business. In this section, Understanding Six Sigma, we're going to cover the body of knowledge elements listed here. Just what does this term Six Sigma mean? A little bit of history on Six Sigma continuous improvement in general. Some deliverables of a Lean Six Sigma project. The problem-solving strategy. How do we develop this whole idea of Y is a function of X? And then who are we trying to satisfy, right? The voice of the customer, our business needs, and also employee needs as we look to improve our processes. What is this sigma, the sigma in Six Sigma? Well, we start with the basic premise, which is the standard deviation, right? The Greek letter sigma, which represents the standard deviation. That's what most people are familiar with. That we represent the mean, the standard deviation represented by this Greek letter sigma. In the Six Sigma methodology, variation, right, is the enemy. We want to be predictable in our output. And so the bigger the standard deviation of the process, the less predictable we are. And in the graphic we see here, the red distribution represents a process with a wide variation, more likely to be a customer dissatisfier, where the distribution in the blue is much narrower, much more predictable, right? We would say that that would be a better customer satisfier. And so as we progress through looking at the different tools, we'll look to see, how do we keep our process both on target and with as little variation as possible. So it's all about being able to predict what the outcome is going to be so that we know that we're going to satisfy our customer with their particular expectations. So the standard deviation calculated, we show the formula here. Some would say it's sort of the average deviation of each data point from the mean. So we take all the data points, subtract the mean, right, square that quantity. We divide it by the sample size n, and then we take the square root of the whole equation. And that just puts it in the same units as the mean. So standard deviation, if our mean is in feet, the standard deviation is going to be in feet. If our mean is in PSI, our standard deviation is going to be in PSI. So that's how we calculate it. And again, the smaller, the less the deviations from the mean, the more predictable and the better we are at meeting our customer expectations. You'll also see on the normal curve, the standard deviation, right? The first standard deviation is that first point of inflection on the normal curve. So we talk about how many standard deviation units are under that curve, and that's what we're going to look at on the next slide. So here we see sigma as sort of a measuring unit on a ruler. So we talk about how many standard deviations as we go out from the mean represent the area under the normal curve. And so if you remember way back to statistics class, if you ever took one, we talked about going to a normal curve table and looking at the area under the curve for certain distances, sometimes we call those z values, from the mean. So in the standard curve, some of the common terms we talk about, plus or minus one standard deviation, we've got 68% of the data. That's where the bulk of the data is. Plus or minus 2, we talk about 95% confidence intervals. All that means is that we're within 2 standard deviations of that average. Plus or minus 3, which we use for control charts, 99.7% of the curve, all the way out to 6, which has virtually all of the area under the curve. The curve does go to plus or minus infinity, and there's still a little teeny bit of area way out there. But when we talk about 6 sigma, we usually are looking at this view where we get out to sort of 2 parts per billion under the curve. And what we want is, since our process is going to have this output, again, the smaller the standard deviation, the better. And we can actually predict with the normal curve how much product is going to be in each of these sections. You know, plus 1, plus 2, plus 3 standard deviations away from the mean. So another view of what we talked about the area under the curve. Now we use the sigma level as our measuring stick to talk about how many standard deviations fit between the mean and our nearest specification level. So in a true 6 sigma process, we have 6 standard deviations all the way back between the specification limit, right, what our customer will accept, this case on the upper end. So that would be a 6 sigma process that we're showing here. If we could only fit 5, it would be a 5 sigma process. 3, a 3 sigma process, right, all the way down to if we could only fit 1 and our specification limit was over here, we would have a 1 sigma process. So this is what we talk about when we say the sigma level. In some companies, like when I was at Motorola, we measured our process. One of the ways we would measure it would be on this sigma scale. How many sigmas to the good is your process? Again, with the goal of having 6. So just another way we use this idea of sigma or standard deviation or the Greek letter in order to describe our process. Here we have some other metrics that we might use to describe our process. And I always say use the one that is easiest to communicate within your organization. So at Motorola, we use Sigma level because, hey, we were a 6 Sigma company. Everybody talked about Sigmas and how many Sigmas their process was. But a lot of people can't relate to the fact that they're on a Z scale and, you know, 1 is 68% and 2 is 95%. That doesn't translate right in their vernacular. So a lot of times we'll use things like yield or parts per million. We can use defects per unit, yield. So whatever works for your organization. And the good news is we can convert back and forth between these different units. And we'll get into some detail about when each one is appropriate and how to do the different calculations. And luckily, Sigma Excel will help us to do a lot of the hard work. We don't have to go look up things in tables and use a lot of calculators, etc. So we'll take a look at all of these different units in a way to measure the goodness of our process, or look the other way, the glass half empty. What is the defect rate delivered to our customer? Here we put it all together for you. We've got the yield, we've got our sigma quality level here from 1 all the way up to 6. Yield can translate into parts per million defective, and then we add in a little cost of poor quality metric. So our sales point for companies is that we typically start in the 2 to 3 sigma range, and I can't tell you the number of times when I do my measure phase for a project, I calculate all of my metrics here, and we start out in the 2 to 3 sigma quality range, which means, hey, our yields are 80 to 90%, right about 68,000 parts per million defective. And the sales point for, why do we want to do improvement projects? Why do we want to be a continuous improvement, a Kaizen type of company? Well, we want to get rid of this cost of poor quality. And later in the presentation, we're going to show you the cost of poor quality iceberg and all the things that are down in there. But you can see that if we move from sort of 2 or 3 sigma up to this 5 or 6 sigma range, we're talking about 20-25% cost of sales, turning that from just getting the product out, right? So scrap and rework and wait times and inventory or lack thereof of inventory turns, and turning that into cash. So, right, you can imagine, right, the advantage is a company that has less than, right, a 10% sort of waste in their process built in to a company that's got 20 to 30%, and what an advantage that would be out in the marketplace. So the whole idea is that as we move up this sigma scale, as we get our yields up, as we get our defects down, there's going to be a cost savings, a cost benefit to doing that. And so that's what's been sort of the bellwether, the benchmark of employing Six Sigma methodologies is, hey, let's go get the cost of waste out of the process and turn that into profit. So what is the Six Sigma methodology, or probably better said, what is DMAIC? Define, measure, analyze, improve, and control. So it's a simple 5-step process, sort of program management, project management 101. These are milestones. We have 5 of them. And there are certain tasks and tools that are used within each one that we will cover as we go through the course. So it wasn't, any magic. You could call this PDCA, which, right, some companies do. Some people use different acronyms here. But it's very simple that I'm going to do about 20% of the work to get to each one of these milestones. And we've nicely apportioned some activities that should take place in order to get from the beginning to the end. So what we do caution is where everyone tries to jump to is just to go implement improvements. There is some discipline in the process to say that, well, before you can really do that, we need to know where we're starting. We need to know that we've gotten to the root cause. And then when we make the improvements, they will actually stick and make that waste and variation go away. So very simple 5-step process, tollgates, milestones, call them whatever you'd like. You can rename it to be whatever you like, but this is stuck over close to 40 years now, and I always say, right, it works every time. So that's what DMAIC means, and we will cover each one of these phases in details as we go through the course. The toolbox that helps support the whole Six Sigma DMAIC methodology is quite broad. There are quite a few tools. You won't use every tool on every project, but it also has a broad set of problems that we can go after. And so when we look down sort of at a y as a function of x down here for right, what does the customer perceive as its value? When we look at dividing that into cost, quality, delivery, or speed, right, it's a function of things like earnings, the product design, so we can work on things to make our products better. We can look at making our yields better. We can go faster. We can look at maintenance type items where our production lines are available to make product. And then also the people side of it, right? What are all the folks that have to operate together, right, as a system in order to support our products and processes. So it's a broad tool set, as we say here. Hey, the tools aren't necessarily designed just for the Six Sigma methodology, but we've organized them into places where they are probably most applied on that framework of the DMAIC process. And to give you an example, when I was in my early years at Motorola, we taught courses at Motorola University on all kinds of tools. Here, go take one on 2-sample t-tests, and here's one on Pareto charts, and right here's another one on process mapping. And they were interesting, and I tried to apply them as I could, within my job. But where we really had the breakthrough, where we really finally figured out this whole idea of Six Sigma and DMAIC, was apply it to a real world problem. Go through those 5 steps. Pull out the tools that you need as you go through those 5 steps. And it was just a night and day difference. So the tools by themselves, hey, they're great. I use a lot of them in one-off situations. But when you apply them to a real business problem, right, going through the DMAIC methodology, that's where we really get the most leverage from the tools as a whole. Oh, this is a classic slide. Reminds me of my early days in Six Sigma at Motorola. The fruit tree. Hey, the good news is if you're just starting out and you haven't really applied much problem solving in your processes and in your business, there's a lot of low-hanging fruit. I can use from very simple tools and get myself from a 1 to a 2 to a 3 Sigma process, right? We can use very basic tools, Pareto charts. We can use process mapping. We can use check sheets and things of that nature, just to standardize how we do the work and to make it better. And then there's some nice things we can do up here when we've got to 3 Sigma, moving up a couple notches on the scale. We use usually a little bit more sophisticated tools. We really have to understand the input to output transfer function. But when it makes sense, right, we try to climb even a little bit higher. And then sort of the nirvana is when you get to the point where I can actually design the process, design the product to be defect free from the beginning. So we talk about right, design for Six Sigma, that this new process line isn't going to make defects, and I'm going to always be able to satisfy my customer. So that's always our aim. Sometimes it's not very hard to achieve. Sometimes it can be quite a challenge, especially when we're looking at technology limits and things in order to make some of our products and some of our processes. All right, so a few quotes from our sponsors or some of the early adopters of Six Sigma. General Electric, I did a little bit of work there, but mostly I was involved in Honeywell, which was then Allied Signal. And you can see, right, it's not a slogan or cliche, right? It's a disciplined process, but again, not very difficult. 5 steps, 5 tollgates, 5 milestones, and right, it's part of the DNA how we do work. So Jack Welch was a big proponent, and he was kind of the one that came up with the idea, right? Variation is the enemy, although that goes back to Duran and Deming and those, but he really took that to heart and said, if my process has a lot of variation, then I know my customer's not going to be happy. Honeywell was one of the first companies outside of Motorola to go after it. Larry Bossidy and his crew, and they really figured out that they could apply it to outside of just the manufacturing floor. They could do it in finance. Right, GE actually did it in their financial arm, and right, Lockheed Martin, Navistar, some others. Right, the savings in just the first few projects just sold them on the whole concept. So right as this whole idea of Six Sigma went outside the doors of Motorola, right, the first companies that went to try it and applied it, right, really found it to be groundbreaking and fundamental to how they were going to use continuous improvement to improve their businesses going forward. This slide shows a little bit of the history, which I was privileged to be a part of most of it. It says here Bob Galvin really kind of laid out the ideas of Six Sigma, and it's interesting. It was really spurred, right, for those that are old enough to remember, was the loss of the Quasar TV business, right? The works in a drawer. And I used to always joke when I'd first go out on the consulting stuff, right? Our TVs are so bad, right? We put all the defective components in this little drawer, so when the technician comes out to fix your TV, he can at least do it quickly. And so, right, if you think, right, Motorola, transistor radios, right, the next level up would be televisions and, right, any other communication equipment that went with that. So that was really a blow. So, right, I was part of this whole idea of, okay, quickly we're going to make a 10x improvement in our quality levels, and we called it the quality system review, which turned into the Malcolm Baldrige quality award. So, right, we kind of chewed off a couple things with our initiative, and right, we came up with the whole concept of right Six Sigma and why we needed 6 of them. The whole idea of rolled throughput yield came in here in the early 90s. Bill Smith, right, is the sort of the father of Six Sigma. My old boss, Mike Harry, worked with him in Chicago, right, coming up with some of the concepts and writing the first papers on the subject. Mike left Motorola in 1984. Right, Texas Instruments down there at the Defense DSEG, and some of the guys at ABB were working on right some of the pole-mounted transformers. Right, they furthered it. Right, they were the first ones to kind of test it outside of Motorola. And then the call came. I was one of these right application experts that left to bring the whole idea of DMAIC and Six Sigma to other companies. So I started at Allied Signal. It was real cool. We got Larry Bossidy, right, the CEO of the company, to say, hey, this is what we're going to do. We're going to use this as our leverage to quality, as Galvin did at Motorola. And it was a lot of fun in the early days. If you went to work at a company to install Six Sigma, their stock usually went up. So I made a teeny bit of money with Allied Signal, Navistar, GE, right, and but it was also during the dot-com days, so right, stocks were generally going up. Jack Welch, right, they were the biggest company in the early days to undertake Six Sigma. Matter of fact, it was so big, even though right some of my peers helped do the consulting, we really met with their quality training group, and as quickly as possible, we transferred over the whole idea of training to be the black belt, right? This training that we're going through here, so that they could deploy it worldwide as quickly as possible. So, right, the few experts that were around in the early days would have been stretched too far to really go to every division within General Electric worldwide in order to make it go. And then the industries that we've been in since, personally, I've worked in automotive industry, the government industries. I've worked for the Department of the Army, TSA, FAA. We've worked in insurance, banking, so you name it. The beauty of the DMAIC process is that if you have a process and you can write down the steps, we can figure out how to make it more efficient, take out some of that cost of poor quality. But in the early days, this is truly what really happened. Started at Motorola, did a little bit of work at ABB and Texas Instruments. Allied Signal was the first company to really try it outside of Motorola. GE then kind of took it to the next level, and then I would get phone calls. Hey, I need me some of these belts and some of this continuous improvement work. Right? How do I make that? How do I make that happen? So a little bit more about what's a sigma and why do I need six of them? Well, it really is just math. So we figured out that for complex products and processes where you've got a lot of things strung together, that if I could move each individual one up towards that Six Sigma level, when I add them all together, I'm still going to get a very good process yield. Or the idea of if I only produce 3.4 defects right at any one step, if I add them together, I'm still really in this low parts per million as delivered to my customer. And then there's a lot of other good things that go with that, right? If I'm really at 3.4 defects as an output, well, do I try to find those? Uh, right? If I have to take a look and see, right, what will the impact of the customer be um, versus, right, could I even realistically find things at that level or that low level of defective? And this all allows for the mean to shift back and forth a little bit. We'll get more into that as we look at calculations of sigma, Six Sigma, and rolled yield. Uh, but the whole idea of the six standard deviations helps us to withstand process variation. And if we can truly get to that level, that we will be very predictable to our customer. And we can do it for very complex products. Like I worked in the defense industry, we had maybe 10,000 parts in a unit. So think of aerospace, airplanes, automobiles, down to some of our simpler products like a pager that only had 26 parts. And so you could really uh, look across your production facilities, and if I could get each process up to this level, good things were going to happen both for the less complex to the most complex products we had in our portfolio. A few other historical tidbits. If you read some of the early works that came out of Motorola, we only had a 4-step process, and we truly did just steal plan, do, check, act, and called it measure, analyze, improve, and control instead. There was a little bit of a method to our madness. So you saw a few slides ago when Bob Galvin asked for 10x and then 100x improvement in quality. What we actually did, rather than just start firing off projects, is we actually did the measure phase for almost, we did for every production process. So if there was we manufactured something, whether that was a circuit board, whether that was a pager, a telephone, we went and figured out what the Sigma quality level was for every one of those processes. So in the 80s up to about the beginning of the 90s, we really executed a whole bunch of measure phases, and then we said, well, the things that we're going to improve are going to be the ones that are the lowest on the Sigma quality scale. So we really started here, and then we did analyze, improve, and control on those low-hanging fruit yield processes, those ones that were lowest on the scale, in order to improve those first, and then go up and up and up until we were able to push everything towards that Six Sigma level. When we went into taking this on the road, and at GE, it was most obvious because they tried to go so far so fast. Well, we needed to get more into project selection. So what projects should we go after? Because they didn't go and do all this measurement early in the game. So we did add that step. They added the step. We then adopted that as now a 5-step process. And the whole reason was, hey, we need to do enough definition of the projects at the beginning to decide which ones we're going to go to work on. So we're going to have this portfolio of potential projects, and then we're going to go launch those through the rest of DMAIC based on the ones that we think have the most return on investment. And thus then the other toll gates, the other milestones here help to make sure we launch the right one. So if we get to the measure phase and we find out that it's not really the return that we expected, we go back and we pull another one out, and we bring that one forward. But yes, it did start out as just a 4-step process, but the reason was we just really did a process inventory in the early days of Motorola and got things through the measure phase. So now, as applied more broadly to other companies, we do this process definition stage in order to do a good job at project selection, so that the ones that we bring forward have the most likelihood to succeed and have a good return on investment for the efforts. So let's put a few tools out here on the DMAIC process, and we'll look at a few different process flows like this as we go, to make sure that we ground you kind of where we are in the DMAIC process as we go through each one of the 5 phases. So when we look at, hey, what are we trying to do within each of the 20% milestones here in Define, it's all about, hey, what project are we going to do? What does it look like? Let's write it down in some way. We need some resources, so we're going to form a team, and then we're going to test it with an initial guess at what would the value be to the customer and to the business. So if we're going to put some effort into it, what does the return on that effort look like? And hey, then we're 20% done. Then we move into measure. We make sure that the metrics that we're going to use are valid. So we're going to talk about how are they measured and how accurate is that measurement. And the ultimate is, hey, what is the current capability, right? Where are we on that sigma scale or yield or parts per million defective? So what is the real quantitative way to look at the problem? And then we start to look at this idea of y is a function of x. So in the beginning, it's just, well, what x's could it be? And we're going to quantify what are the particular outputs that we're going to try to improve. So, a process could have dozens of outputs, and what we're really going to look at is the one primary and a few secondaries that we're going to try to improve. Next, we look at root cause analysis. So those x's and y's that we hypothesize here in the beginning are not all important. And what we find is we could come up with dozens of potentials in our list of x's that impact our y. And eventually, as we get down through the process, we find out it's sort of 1, 2, or 3 that are really important, which is a good thing when we get to control. So in Analyze, we really torture the data. We think there might be an X and Y relationship. Okay, well, let's prove it or disprove it. So we'll look at graphs and charts and finish off with some statistical hypothesis tests. Does X really drive Y? All right, then we move into improve when we can, and we like to then take the relationships that we think are there and actually test them in real life. So as we change the x's, the inputs, can we see the y actually move? And we do that through regression or designed experiments. All right, once we understand our y is a function of x relationship, we move into, hey, now can we use that information to come up with solutions? We start talking about implementation plans for how we're going to make the process better. And then probably the most important phase, but the one probably with the least statistical tools is, well, now how are we going to keep it there? And so if we figured out how to make the process better, how are we going to control it? So let's validate that we did get better. We're going to talk about a control plan and a reaction plan in order to keep the process at the new, better level. And then finally, validate that, hey, the cost of poor quality savings we thought were actually achieved. And I don't know, I find many times we do better than we thought in the first place. But even if we get 50% of the way or 75% of the way there, we did get some savings, and then we can move on to the next project. Here we take the define phase to break out some of the activities that we will go through in order to get our project started, and we'll talk in some details here. But first, at a high level, what is the reason we want to write a project? Well, basically, let's call that a business case. What's the business reason to go out to fix something? So maybe our customers aren't happy. Maybe it costs too much to do a particular activity. Maybe we're throwing away too much product. So we're going to start off with a business reason to go forward. We're going to assign some resources. So one of the resources will be someone like you who's taking this black belt class, because you are the competency holder. We're going to teach you tools and techniques. We're teaching you the DMAIC process. So you will be the keeper of the process, and you will help lead the team through sort of the statistical or data journey to get from beginning to the end. You'll also have some team members, some subject matter experts. So we don't expect any one person to have all of the answers, but to gather a group of subject matter experts that know the process, right, know the customers, know the business itself, in order to get from the beginning to the end. We talk about stakeholders in the general sense of they're the interested parties in having something made better. So they might be process owners, they might be managers or plant directors, but somebody that's interested in this business case being made better. We then write a charter, so sort of the formal, what does the project look like, who's going to work on it, what is the timeline, and we'll talk about the specifics of that here coming up. We scope it, so what's in, what's out, and that's a very important step in order to define success, because if we try to bite off too much in a short period of time, right, we might not be successful. So I can tell you a number of times where if you start small and get there fast, it's a lot better than trying to do it across the world for all processes to satisfy all stakeholders everywhere. Right? Sometimes you might still accomplish it, but it will take a lot longer than if we can make it into some bite-sized steps. We start off with another way to do scope is, well, what the heck is the process that we're gonna work on? So if I look at what I call the left boundary and the right boundary, where does the process start? Where does the process stop? And that's the portion of the process that I'm going to try to improve. We estimate the savings. Hey, so what is the reason for the business case? Is it taking too many hours? Is there too much overtime? Is there too much scrap? Is the customer satisfaction not at the right level, or some combination thereof? But there will be a right savings of sorts that we will estimate. When we get to that point, we've developed our charter and estimated sort of the return. Right, we're going to have a decision point. Is that the one that we're going to go forward with? If yes, right, we get the resources approved. We get the business lead and/or the process owner to commit the resources and commit to the timeline, and then we're off and running. And really, at that point, we're into the measure phase. So, right, this idea of the define phase, is not really that difficult. It's good to do a thorough job to make sure we scope things correctly. But that's all there is to it. If we can define what we're going to work on and who's going to work on it, we're ready for the next step. We do put the decision point in here that if we don't like the answer, right, we're not going to get enough cost. We can't really figure out what the scope is. We can't really assemble the resources. Hey, there's plenty of things to work on, right? So we show, hey, let's just start over. Let's go pull another idea out of the hopper and bring that one forward. So I've been working on a continuous improvement for almost 40 years now. I'm still doing it, so there's never a lack of processes and projects that we can go to try to work on. We'll talk about this towards the end of each phase, right? We'll have a set of deliverables. We'll talk about a Tollgate review. So some of the things that are in the define phase, some activities or some actual documents or data outputs that we might produce are listed here. Right, we need to know who is going to be our team. What are we going to measure? What measurement are we going to improve? That's what we call the primary metric. I talked about a high-level process map. What portion of the process, or what process are we working on? And so we want to be able to at least show that in a couple blocks. What do we need to be careful of, right? So as we improve one thing, we don't want to make another thing worse. So we're not trying to sort of squeeze the balloon and move the bubble back and forth to different departments or to different sections. We'll talk about some lean tools. So can we lean out the process, right? Make the workflow better. Who are the stakeholders, and right, what is their involvement in how the process or project moves forward? A little project plan. Hey, we made it simple. 5 toll gates, 5 milestones. When do you want to get them done? And we can move very fast if we have the resources to do that, right? Or we can go along as the resources are available in order to execute through the whole DMAIC process. And then we constantly look out for roadblocks, and we're going to talk about roles and responsibilities of different players to make sure that we continue to move forward, that we can overcome any of the roadblocks that we might run into. And again, that's why we involve stakeholders. That's why we ask for resources before we start, so that we can minimize the number of issues and barriers that we might have going forward, like time to do the project, like access to the process, etc. So when we look at the whole Six Sigma strategy, the DMAIC process, you've probably heard me say 100 times already, process, and there really is an emphasis on fixing the way the work is done, the way that business is conducted, in order to make the output better. So we can't just go move the outcomes without knowing how the outcomes were produced. And again, it's a wide range of things that we can look at. So we can look at metrics that might be on a month-end dashboard. If we don't like the numbers, well, let's go try to improve them. We can look at things like how long does it take to do an approval? Who should be involved in the approval? Do we meet our plan or not? So we can look at some gap analysis of if we've made financial plans, do we usually march in the right direction? Can be applied to people processes like recruiting and hiring, and we actually call our process to in all the personnel moves, we call it the hire to retire process, and all the little pieces that happen along the way, and we have process owners for that. So it can apply broadly in all areas of the business, and we call it a breakthrough strategy because it can handle all those different types of business processes, and we include a wide range of tools. And when we look at how do we measure success, it can be in lots of different output metrics. So it can be purely financial. It can be hours saved. I've done a lot of projects on voice of the employee. So is it fun to do this process? Do I feel like when I come to work this month that I've been empowered and able to do my job in an efficient manner? So if we really look at cost of poor quality in a broad sense, and again, we'll have our little iceberg coming up here in a minute. Hey, there's a lot of things that aspects that we see kind of above the waterline, things that are easy to measure. But then there's also sort of these lost opportunities that go along with the things that we can actually see and measure. So we're going to use this as our engine to take processes, measure them, make them better, step and repeat. So we'll continue to use this simple DMAIC process to attack business issues, and then as we make them better, we go on to the next one, and you'll see sort of this repeating engine that once it gets rolling, it's a pretty fun thing to continue to make things better. So going back in time some, uh, one of the things right in a conventional, right, 1-2 sigma process was just simply, hey, I'm going to produce things as long as they are within my customer limits, right? They go to the ship table, and then I probably have some really neat little processes that take the bad ones and finesse them to go into the good side. And then what we typically say is we got some sort of a yield, probably in the 90%. So with whatever I started with, if I started with 100 input units and I got 90 right output units, right, I had a 90% yield. I patted myself on the back, and right, this stuff just went to the scrap heap, the garbage pile. Maybe I could recycle some of it, but that's really the way we looked at how to get things to market, how to get things to our customer. And what we're going to say is, well, we really need to look a little bit stronger at, well, how much of this can we do the first time, and can I get rid of the finesse uh, extra processes that move the stuff just into the conformance area. And we'll even look at, hey, the closer I can get on target, perhaps maybe my customer is even more satisfied as I shrink the variability in my output. So we're kind of going to try to move away from, hey, I can get it in the spec somehow, some way, through miraculous acts of people, to being very predictable that I don't have to do these types of things. And actually, I produce very little in the bad pile outside of my spec limits. The DMAIC problem-solving strategy does revolve around a very simple, right, mathematical concept that I have an output that I'm going to try to improve, and its level, its variation is driven by something. And right, we're going to say that it's driven by the inputs, process variables, the way in which the process is conducted. Our job through the DMAIC process is to find out, well, which ones of those are important. So in the old days when I was looking at making things better, right, our Y would go bonkers, whatever that is, right, it would go out into left field, and we'd say, oh, we need to do a process improvement activity. And so we would simply, everybody together in a room, we'd write down on the board, and we'd say, we need to fix all of these things. And sometimes it would be 5 things, sometimes it would be 12 things, sometimes it would be 20 things. And so we'd come up with an improvement plan, and we'd go try to fix all those things. And usually for a short period of time, the Y would get a little bit better. But we had no idea, what the function was. Were those X's important? We just said, hey, we think they're important. Let's go fix them. And then sure enough, the Y would change again, go in the wrong direction. We would scratch our heads and say, well, we already fixed these 12 things. Now what? So we might try it again and right, and then fail again. So the idea of the DMAIC process is to really get to the heart of, we have an output. There are some inputs we probably don't know exactly what they are at this point, that really impacts the performance. And so our job through the process is, number one, put the big list together and then whittle that list down as we go through to make um, our understanding of the process and the function of what inputs drive the output and by how much. So it's really that simple or that complicated, however you'd like to look at it, but you'll hear us say y is a function of x over and over and over again. And the whole idea is that through DMAIC, through the problem solving strategy, we can come up with those few inputs that are really important that drive our output. Here's a simple example that might help us with even project scoping, because we may not even want to look at these things right as a whole. Sometimes we might, if that's what it takes to make it happen. But I'm going to focus on the bottom one here. I've worked in our global business solutions department here for the past 6 or 8 years, and very familiar with the end of the month closing process. One of my favorites. Well, the length of time that it takes in order to do that closing. Right, we're going to start off with well, how far off are we? Right, we're going to do a little trial balance. Right, we're going to do some corrections. We're going to look at all the sub accounts and right, do they flow up to the top? Some of my favorites, we call them journal entries, right? Or credit memos. So, right, how do we move money to different places and account for the fact that something hasn't arrived or been paid for yet? And then finally, right, are there errors that find their way into the trial balance and so on and so forth? And after a number of days of crunching and crunching, right, we fix these inputs, and that takes a certain right number of days in order to perform that. So if we're going to try to fix the right time to close, we're going to have to focus on some of these right lower level inputs to make them better. Which one? Well, we probably could figure out where should we start, right? Is it data entry errors? Do we have too many sub accounts? Not enough sub accounts? Right? How far off is our trial balance when we when we go to close? At the end of the month. But by breaking it up into these pieces, we can see that right this time is a function of all the steps that are right underneath it, and you can go several levels. So we could look at the way that we roll up the sub accounts, and we could have a sub process to that where we have y of the sub account time is a function of these things, and you can continue that down for several levels, and we'll take a look at that when we get into process mapping and scoping of our project. But very simply, if we look at some output that we want to improve, we can start to quickly think about, well, hey, what are the things that could impact this time? And we have, some process knowledge that would tell us, well, gosh, we never really close on our first trial balance, right? And gosh, we write a lot of these credit memos, and I know we're always sending some files back to get data entry things checked or fixed, and so this is where we start. And through the process, we're going to say, well, which ones of these are the most important? And then we might break these down further to write even further subsets. So we get sort of a hierarchy of X's and the X's that we need to improve our output. Thinking of that idea of y as a function of x, here's a simple exercise to do in your head here as we go through the slides. So pause the video here after I explain this. So you're going to have a tailgate party. I don't know if it's for a football game, a soccer match, a baseball game, and how would you define right, success? How would you know you did a good job in planning a successful event? So what are the factors that you would need to consider in order to have, right, a successful party? So just take a few minutes and write down or might remember in your head, but write down a few things. Right, what are the X's that you would consider in order to have a good tailgate party? So you can pause now, and then I'll give you some of my ideas. So what did you think of? Well, who are you going to invite, right? So there's going to be an invite list. Where is the location? So is there a spot that is already designated where people can park, or is it some lot where it's sort of first come first served, and you're need to going to go there early to stake out a space? What kind of food are you going to have? Do you need a grill? Do you need to pick up some sub sandwiches? What kind of right drinks are you going to have? And right what kind of ice, and am I going to meet the needs of everybody there? Do I have some water? Do I have some vegetables if people are right vegetarian on the food side? Do I need chairs and tables? Are you going to really do it up and have a generator and a TV and watch some of the pregame festivities before you go there? So you can see the list can be pretty long, and right, which of those things is probably the most important to have a successful party? So I can come up with a checklist. Right, the nice thing is I can assign this to different people that are going to come to the party. Right, you bring these drinks, you bring this food. Hey, you get there early. Hey, can you bring your tables? Hey, everybody bring some those foldable chairs so that we have a place to sit. Right, garbage bags to right clean up afterwards. So just something even as simple as right a tailgate party or a birthday party or right, would have this idea of y is a function of x, right? In order to be successful, right, these are the elements that need to happen in order to see that success. Continuing on with the idea of y is a function of x, and sometimes we call this the Deming funnel. You'll see this in the analyze phase slides. Hey, there's a lot of x's, right? I've done some brainstorming on some processes where we've come up with 20, 25 inputs. Matter of fact, somebody asked me the other day to look at it, designing an experiment for them, and we went through the process, and I think we found 37 different input variables. Well, it's too many, right? I can't control all of those. So through the process, we are going to funnel down through different tools to find out, hey, does this X8, whatever it is, have a relationship with my output? How about X9, right? How about X10? What we'll find in the end is there's really just a couple that we can really demonstrate have this mathematical relationship. This y is a function of x, and we can leverage that, right, as we're showing over here. Well, if I only have two things to control, wow, that's a lot simpler to think about devising solutions, uh, moving into the control phase to put controls on those. If I've only got a few things, right, versus trying to do it for everything. So we call this the trivial many inputs versus the vital few. So you might hear us talk about that. But this is the beauty of the process. And in my almost 4 decades now of doing this, it's amazing how this works out. There's only one, two, or three variables that I really need to pay attention to out of the whole gamut that impact a particular output. Slide shows our ultimate goal. When we get to the end, we should be able to uh, show that we were able to take a process from some not so good level down to a new level, and so we can move the average back onto target and look at the variability. Right, we've got a lot of variability here, and look at how nice and tight the variability is after we've made our improvements. So this is the ultimate slide I like to show at the end of the project that, hey, here's where we were. Uh, Not really good. We had a lot of variation in the process. Customers not very happy. Right, if these are defects, right, that we're throwing away, uh, then we've got a lot of cost of poor quality. And then through understanding what X's are important, we're able to shift the process in the good direction, get better performance, and also better consistency. So we will be able to show graphically, numerically, through the DMAIC strategy that we were able to make this improvement. So this is sort of my capping slide at the end of every project is, can I show how I've made an improvement from where I was to where I will be into the future. Our project that we select to go take through the breakthrough strategy can come from a number of places or some combination thereof. And we'd like to show this as a little bit of a Venn diagram. So the primary reason could be that we're trying to make the customer happier. The primary reason could be because the process costs too much, or the business isn't happy with it, or the process could start with, hey, this is a very difficult process for employees to execute. And I've done projects right from all of the different facets, but there's also usually a lot of overlap. So you can imagine that if a customer is unhappy and we're losing sales, right, that can impact the business. So we have some overlap area here. From the employee perspective, hey, if we hear our customers aren't happy, this would happen in my factory all the time. Or hey, the employees take that personally. Why is it that my output is not right, making that customer satisfied? What can I do differently to make that happen? So we will be looking at these voices and what's the primary, and you're right. How does it sort of overlap in some cases? Uh, Ultimately, right, everything's about the customer who pays the money that makes the business run. But projects may start down here lower, where we're looking at a particular business reason that we need to do some project work. I really have some fun with some of these, hey, employee satisfaction ones that typically go over to the business and also to the customer. I'll give you some examples of some of those. So we'll go into more detail, but a lot of times we talk about VOC, VOB, VOE. Well, that stands for voice of the customer, voice of the business, and voice of the employee. And this is back in the where we're looking at the business case to start a project. It probably came from some of these voices being loud and not very happy, that we're going to try to rectify it. There's a people side to deploying the Six Sigma methodology and strategy. And right, it's got a sort of network of experts that you're becoming a part of, right? We're going through the black belt material here. And then there are some support structures with executives and champions over here on the right. And we'll talk about some of the roles and responsibilities of each. So we do have a competency scale that we take different belts through, and we have different levels of achievement. Down at the yellow belt level, right, these would be folks that do the process right, every day. We might train them how to do a control chart, do a simple map, uh, keep track of some certain metrics, use some very simple tools like check sheets so that they can be good team members and they can be right an extension of the overall improvement effort. Right, then we move up to right green belts who right have the ability to work a simple DMAIC project, usually within their work area. Black belt is sort of the more jack of all trades, where you can work cross-functional projects, projects that are either in your area or out of your area. And then we have sort of a mentoring network that sometimes this can be consultants in the beginning, or you might hire somebody with a lot of experience to help right at all three levels, wherever we're doing more sophisticated analytics and analysis. So let's take a look at right how this all kind of works together and what the roles and responsibilities of each one of the group. So typically a deployment or a decision to make continuous improvement part of the business fabric starts somewhere close to the top. You saw in the history, right, it was driven by Bob Galvin at Motorola, my CEO, driven at Jack Welch at General Electric, Larry Bossidy at Allied Signal. So many times in my consulting role, right, we would go meet with the executive leadership team, right? They're going to make the initial decision that, hey, we want to go forward, we want to do something to make our business better. At the top level, they're looking for, hey, I want to be able to, right, see business improvements. You know, bottom line gets better, my customers are happier. Right, they're going to do the proper level of promotion through the business. Those are simple things. Maybe they make write a video. Hey, we're going to do these things. They post it on your intranet site. What I really liked is it was not unlike Jack Welch to make it to some Tollgate reviews for some of the projects. At Bechtel Corporation, Riley Bechtel would come. We would have a quarterly sort of science fair of projects, and he would walk around and talk to the teams that did some different improvement efforts, so he could get a feel for what some of the efforts were doing throughout the business. So they kind of play a sort of a cheerleader role, but also at the top level, hey, they expect right to get some results that right make the business better for their shareholders. At the execution level, we typically are talking about a mid-level to higher level manager, director, executive director, manager that is either a process owner and they want to make their processes better, or they look at their right yearly objectives and say, hey, in order to get there, I'm going to have to do one of these breakthrough projects in order to meet my goals. So they're going to help to select projects. They're going to help assign resources. So they are usually the owners of those resources, you being one of them. So they're going to put those resources together. We do like for them to participate at those different milestones: define, measure, analyze, improve, and control, which is good in two ways. One, they understand that the execution is going as expected, but it also gives the team and you as the project lead and right an interaction to make sure that you're getting the support that you need. So as things shift and drift, right, you can talk through, right, do I need different resources? Do I need additional data? Do I need support from an outside organization? And right, that's what we look to be. The champion's role is to make sure that the project execution continues in a positive fashion. So there's some time commitment, just like there's a time commitment from the team and the you as the project lead or the belt, hey, they need to do these project reviews. They need to help put the charters together. They have to help launch the team. So, right, some fraction of their week, usually not a big one, but some hours per week would probably need to be spent on the effort, and they will need to balance their schedule and put time in order to make that happen. So we always say, from your perspective, make sure you have a cadence to meet with your process owner and your champion, so that you're never delayed by the fact that you can't get on their calendar, or don't have time to talk to them. Hopefully it doesn't have to be as formal a process, but we say, hey, start off with a cadence with some formal check-in points in order to make sure that that's not what slows you down. All right. So then through the belt hierarchy. So masters, that's what I call myself. A long time master black belt, highest level of competency. Really, it's a black belt with some project portfolio experience. When we develop them, we're talking 5 or 6 projects that they've led or they've mentored. Obviously, the more projects you work, the more experience, the more pitfalls you've seen, and they're going to work to get the deployment started. I don't know how it will be at your particular company, but these can be hired from the outside. Sometimes, I did consulting for 20 years where I came in as the temporary master for that company, developed the black belts, developed the masters of the future, and then faded away, and the new masters continued to lead that. Masters can do large projects. In my role now, I do cross-business projects when we can't figure out who owns what, and we want to make improvements. So I might span purchasing and quality and engineering in order to look at a particular project that requires all three to play nice together to move things forward. Many times these are the trainers, I'm conducting some training here. Have a portfolio of black and green belts. Always showed you kind of the hierarchy. We'll look at that again, but usually as a master, you'll have a number of black and green belts, at least dotted line, reporting to you. When I worked at Verizon, that was my job. Is I had all of the black and green belts in the sales and marketing organization, and I was responsible to make all of their projects move forward. Make sure they were trained, and we executed on those projects together with the business representative who was a director. There's always a change management portion to it. So, getting the right folks together to make the change happen is always important. We'll talk about some more of that as we go on. There's always a people side to change, and then kind of establish that DNA. So, as we do DMAIC and DMAIC and DMAIC and DMAIC, it becomes part of the culture. And it's fun now. I've been in my current role for about 8 years, and you get a call now, and someone says, "Man, we're really having a problem. I think we need to do a DMAIC project on that." And I always kind of smile, hey, people realize that using this 5-step process can help them to get to where they need to be. All right, the next level down, or maybe the highest level in your organization, black belt, designated to be a leader, at least in the beginning stages, maybe coach and mentor some green belt projects in the future. You are the keeper of the process, So we'll say that a few times. We want to define, and then measure, and then analyze, and then improve, and then control. And so some of the work is to say, hey, we have a methodology to get there. We don't want to just go in and change things and tamper with the process. So you may be called to do things within your current functional role, and may be called to do some things with adjacent functions, again, upstream, downstream, to improve processes. All right, contribute to the right organizational goals. So every year we're going to look at the compilation of projects, the compilation of savings in order to move the entire organization forward. So you probably will have some slice of that responsibility, but it's kind of nice how things roll up and uh, how the return on investment side of DMAIC really speaks for itself. So I'll give a little story that the Department of the Army that I was working at the time decided that, oh, we don't need to do this, DMAIC stuff anymore. And so, right, my whole group was gonna go away. And so we did get a meeting with the sponsor, who was a 3-star general. We walked in with our project portfolio, which had, I don't know, 10,000 projects and I don't know, it was 15, $20 billion worth of savings. And we said, sir, before you pull the plug, we'd like to at least show you, the work that we've done and how much we bring to the organization every year. And we said, kind of puff our own chests out, but where else, what other organization can come to you and tell you, right, this is what they saved for you in the past years? And he kind of looked at it and said, okay, keep going, keep doing what you're doing, right? Because, right, there's nobody that can really talk to, hey, we had this many people work this many projects, and right here are the savings that we delivered. All right, and then you become the technical expert on the tools, right, that are inside DMAIC. So if somebody needs to do a Pareto chart, right, you're going to help them, right, put that together. If they need to do a 2-sample t-test, you're going to say, hey, here's the data we need. You're going to put it into Sigma Excel and help interpret the results. So that's kind of a fun role that I still enjoy to this day is, hey, give me the data. I'll help you to interpret what it says. So some organizations have masters and black and green and yellow belts. So if you decide to deploy green belts, uh, they can do projects mostly in their business area. We don't train them in every single statistical tool to the level we're going to go through here in this class. But you can get a lot of leverage if you're doing right 10 small projects in a different business unit that report up through you, right? There's a lot of leverage to getting those 10 projects done, even if they're small ones, in order to add up to a total. So they usually work projects in their existing functional area, right? They usually are project leads. They will work with you in order to right, achieve their toll gates and to move through the DMAIC process. And right, they learn as they go. So right, green belts will become future black belts and move up the chain. Some companies will have formal yellow belt training. Typically, this is for the team members, the subject matter experts that are going to support projects. So get everybody in the know. What is it that we want to? They know the basic DMAIC structure, that we're going to use a data-driven approach to fixing things, and how they can support those efforts. So sometimes we call them the 7 basic tools, but right, they would know how to put a process flow diagram together of their work area. They might be able to do a little fishbone diagram, maybe construct some Pareto charts, but they become a really good subject matter expert for any improvement team that you're trying to put together, since they know the basics and what it is that we're trying to accomplish through an improvement project. And again, just like for green belts, hey, if they decide that this is an interesting thing, they're really interested in data and data-driven decisions, right? They may be next candidates for a green belt class or a future black belt class. So here we show, the typical support network. Sometimes it's formal where it's direct line. Most of the time it would be more dotted line. You would know as a black belt, right, who your support structure up in the organization is, and then as you become good at your craft, you might have some green belts or yellow belts that you work with all of the time. And the idea here is the leverage that you can get. So, right, as a master, right, I might have 10 black belts that I'm helping mentor, train, right, bring up to my level. Right, each black belt might have 10 green belts that are in their portfolio. So, you have 10 to 1, 10 to 1. It's not unusual for me to have 100 to 200 projects that I have my hand in some fashion in order to do Tollgate reviews to help either the black or the green belts execute those when necessary, and even do a few projects right on my own that are more cross-functional across business units. But the idea is, how far, how fast, how deep into the organization can we get? And it's also nice that if you use this type of structure, at least at the green belt level and probably at the black belt level too, you can develop local right centers of excellence. So it can be at a specific geographical location, it could be at a specific building, specific department, so that there's always somebody close by that we can go to for help in executing a project. All right. So, hey, what can you expect? Right, you're going to go through this training. You're going to become a black belt. I don't know. Maybe I sometimes call this the scare slide. But hey, I've made a career of it. I love it. So, I hope that you love it to an extent too. Uh, but hey, you are going to be a team leader, and you're going to have to use some project management skills. You're going to have to use some change agent skills. You got to get your team moving in a direction. You got to communicate with leadership. You got to schedule meetings and get activities done. So I found it a great learning experience, especially in the beginning. I didn't have necessarily all of those skills, but after your third or fourth project, you get pretty good at it. Right, it gives you a chance to do technical reporting to your peer group and above. Right, it's not unusual for you to have to get up in front of some of the leadership team to show some results. Uh, we do give you a support structure, so you have some other black belts and masters that you can go to, and those networks are really important. So you'll see that right as you have other folks that that are going through this program, maybe have a weekly call or a monthly call and compare notes and right, call each other up on the phone, because some of you will get better at one tool than another tool, and hey, leverage that network. And the real right feeling of success is when you achieve that objective. So it's really a little bit of chaos in the beginning when you're looking at, well, I got to do my define phase, and I got to do my measure phase, and now I got to find my root causes. But if you follow the process, right, more than 9 times out of 10, you will get to the finish line, and you'll be able to demonstrate that you made an improvement to that process, and that's always a great feeling in the end. And right? And you just keep building on that success. So we're going to give you the training you need to be successful. Right, we will talk about your different roles as a change agent as you go through. But remember, right, you're going to have to do some of the blocking and tackling, setting up meetings and getting your team together and doing some communication up and down the chain to move your project forward. Roles vary a little bit by organization, but this is quite a typical template. There's typically a certification process where you'll get, a certificate of achievement. Might be internal from your company, or there are external certification agencies. But basically, go through the course, complete all the exercises, and then where the rubber really hits the road is doing some projects. And again, we found this at Motorola. There was, I don't know if we lucked into it or what it was, but as soon as we started to take all of these various tools and apply it to a real business problem, it stuck. And so that's where the real learning happens, is to do it in a real process. So typically, a couple projects in your portfolio get you to that black belt level. And then really from the business perspective, what does the business get out of it? They get the business results, and you get the feeling of you help to contribute to that. So the coursework plus a couple projects usually gets you to the black belt certification level, and there are some variants on how that might be applied in each organization. Well, again, in order to be successful, this is what we talk to your leadership. We need certain organizational behaviors to be in place. We need leadership to support the improvements. Walk the talk. Go to Tollgate. Look for the compilation of projects and how it's moving the business in the right direction. Do encourage and award people for completing projects. Are you going to give certain rewards for exhibiting the behaviors? It can be anything as simple as we used to give away little badges for how many projects you completed, to financial rewards for achieving certain milestones within the program. We look for managers to eliminate the functional barriers. So if we need different resources, hey, let's get them all in the same room and let's make the project move forward. And then this idea of this is a system that we're putting into place to do problem solving, and to make processes better. And we have to recycle through that that DMAIC process. So we can't be doing DMAIC in one area and then firefighting in another, and let's pick the best answer of the day someplace else. So if we were adopting that we're going to do a Six Sigma strategy deployment in the business, we should use that, and use that to make the data-driven approach to solving problems. We've reached the end of our first section here. So we've covered the objectives of Six Sigma and the Six Sigma program. We've talked about the key, variation reduction, and then we use this Greek letter sigma, which is typically used for standard deviation. So we want a small standard deviation, but we can also use it to count how many standard deviations fit between the process mean and a specification limit. And if we can count 6 of them, we're in really good shape. We talked about the implementation model, which is really On the process side, it's following the DMAIC process, DMAIC. And then the people side, we talked about the roles and responsibilities of management and the different training that you might do for the different belt levels, including yourself at the black belt level. If you're using this as part of your study for one of the standardized black belt exams, these are the body of knowledge elements that we covered here. The meanings of Six Sigma, history of Six Sigma. We went through from Motorola on to GE and beyond. Deliverables, and we'll talk more about deliverables in each section. We covered mostly the deliverables of define here, but we'll continue on that journey. The whole idea of breaking a process down to a simple math formula, that the inputs are transformed through some function to get an output, or said the other way, the outputs are some function of the inputs, and the fact that we have different voices that we need to listen to in order to start off projects at the beginning, right from that business perspective. So are we trying to help the customer, the business, the employee, or some combination thereof through execution of a project? All right, we call this section number 2 in the define phase, Six Sigma fundamentals. We're going to talk some of the basic blocking and tackling elements. So some things will be metrics, some will be philosophy, some will be some actual tools that you can use on your project. But again, some more background to get us in the right framework to move forward with executing a Six Sigma project. All right, so some of the topics that we're going to cover here. What is a process? We're going to cover at a very high level. As we move into measure phase, we'll get into some more detailed types of flowcharts and maps and the like. But we'll use it here in order to say, what's the process view? It gives people a way to ground themselves into what the improvement effort is going to be all about. We start to talk about voice of the customer and how to turn that into, well, how are we going to measure what the customer wants and how well we're able to execute against that. We're finally going to show you that little iceberg and all of the things above and below the waterline. And then finally, back to those metrics, those things like Sigma quality level and DPUs and PPMs, and how we might calculate those and translate back and forth between them. So we talked in the last section that this course is very process focused, and so we say, well, why do we do that? Well, it helps us to understand and describe how work happens, and we can see how work moves through the business and works upstream with our supply base and downstream as we deliver things to our customers. Being able to see it, right, the picture's worth 1,000 words. So if we look at the flow, right, we really can understand what it is that is happening. And from a perspective of, right, it's not the people, it's the process. So as we see that the process is not efficient, the first level defense is, well, we must need more training. Let's go, right, get all the people in the world. Maybe we need higher skills. Well, let's make sure that the process itself gives us a chance to be successful. So we say down here, right, the definition, right, a repetitive and systematic series of steps or activities where inputs are modified, inputs are turned into outputs, right, to achieve a value-added output, right? So what are the steps where we take the inputs, do some value-added activities, and produce an output? right? One step above this, I always say a business is really just a series of processes or a group of processes that fit under one roof in order to meet a business objective. So that's why we look at it from a process. We're going to take inputs, add value to them, create outputs that we can sell to our customers. Well, I can tell you that as you go through, and especially after you finish this course, you'll certainly look at processes in a different way. And maybe we don't think of them that way, but hey, there's processes all around us, right? So, right here in Michigan, it's not so much paving roads as it is filling in potholes. The other day I had to change a tire, right? There's a process. You got to get the jack out. You got to put it in a certain place, right? Get the spare out. Don't do like they did on Christmas Story and lose the lug nuts. Opening a bank account, reconciling, right, your checkbook at the end of the month. So you have internal processes that you use in your life, and your business has processes that it uses to satisfy their customer. And so I can tell you that from this point forward, whenever you're standing in a queue, you're going to start to think about, well, what's the process and why is it causing a line to exist? And why does it take so long to get through the process? So it becomes a little bit of a curse that you'll see things from a process vision, and you'll always want to say, well, how could I make that process better? Okay, so here we're going to look at our first tool, a good old process map, or just a simple flow chart. And we use it in the beginning in the define phase to just talk about, well, what's the process that we're going to try to improve. And so we usually define, I call it the left and the right boundaries. We're going to have a start point. We're going to do some things that hopefully add value to our customer. And then we hand it off either to the customer themselves or to the next step in the process. So we use it to identify flow. It also can give us some feel for complexity. So how many steps does it have? We'll look later at doing process maps that have departments in them. How many different types of resources do we need? We can start to identify rework loops. So I'm going to look at the product here and say, okay, if it's good, it continues. If not, right, it goes back either to step A or step B to have further work done. So, again, very simple look. I really like it in this part where it defines my left and right boundary in terms of scoping what it is I'm going to work on. All right, it's important, and we'll talk about this many times, what's really happening, not how it's supposed to happen. And so therefore, hey, maybe your sponsor or your director used to work in that area, and they're going to write it down on a whiteboard or on the back of a napkin like my boss does. But that doesn't mean that's how it really happens today. So we always say, hey, go out, talk to the people that really work it, go out there yourself, and draw out how the process works today. And we're trying to stay at a very high level here, so we're not trying to get into the nitty-gritty details, but in general, what happens from start to finish, and what are the steps involved in the process we're going to improve. Right, there's some different tools out there. You may choose to go total ham on process flows. So there's Visio. I just typically use PowerPoint or Excel or something. SigmaFlow, iGraphics. There are all kinds of mapping tools available out there. We've gotten into some of the whiteboarding programs where you can just let everybody contribute to the overall flow. but don't make it too complicated. So, right in my years of experience, as soon as the 3M sticky note came out, um, hey, as a square or a rectangle, right, it's a work activity. Turn it 45 degrees, and it is a decision point. Connect it with arrows, and you have yourself a nice flow chart. You can add some different, more complex things as we go along. I do like to show the beginning and end as a green circle or ellipse to start, and a red one at the finish. If you need continuation onto different pages, right, you can say go to right point one, and to two, and to three, if it right is going to flow over to a number of pages. But again, in the define phase, we're trying to stay high level. I always say 5 to 9 steps if you can summarize it in that fashion. Just to reiterate, in the define phase where we are starting out, our first step in DMAIC, we want that really high level map. Again, more as a communication tool. Hey, this is the process. It does start to define scope. So I always say, what's the left point? What's the right point? And our project has everything to do inside of here. So we're going to kind of ignore what happens upstream and downstream. Now, this is our first pass at it, so we may expand if we need to. But this is our opening bid. So we want major steps. Eventually, we'll add more detail. What are some of the high-level decision points? And then, how does the flow go? And then are there any sort of rework loops where the product or the process goes backwards? So, we have a really high-level map. And again, we'll look to expand this as we continue to add more detail. So in order to kind of keep along with the different topics, we'd like for you to think about for the project that you're going to work, or maybe a project you've worked in the past, what was the high-level process map, right? What are the 4 or 5 steps that it took in order to define what the process? What's the left boundary? What's the right boundary? So take a few minutes and see if you can't draw sort of that high-level map, and save that, and then we're going to continue to build on that as we move forward. So stop the video here and take a few minutes to draw out that high-level process flow. All right, with that high-level process flow in hand, let's talk about customers, right? What are they saying? What is their voice? What do they need from our process? All right, so one of the first important questions, do we know our customers and do we know what they want? So one of the early things we want to develop and know to some extent, at least for our metric when we get to measure phase, is who are our customers? So do we know them? And what do they want? And one of the tricks is to take those voices, those verbatims, those things that they say that they want, and turn them into some type of a measurable quantity where we can prove as a business that we meet those requirements. So sometimes that's very simple translation, and other times it's going to take some work to go from that voice to how we will mutually agree that we've met that expectation. All right, so retouching on the last slide. Hey, it seems obvious. Hey, we make things or we provide services to satisfy customers, right? That's what we're in business for. So we must know what they want, right? Or do we? So, right, there's been many a project in my career where solving some of the voice of the customer and refining their needs and their wants has gone a long way to solving their problems. So we can look at it some different aspects. Well, what things does the product or process have to provide? Right? What do they expect and need? Right? How do we know we have the right list and write the uh, complete list? Right? From an integrity perspective, do customers right trust that you will right deliver things on time and to the correct right quality level? So right, do we already have a nice established um, relationship with our customer base, and that they come to us because we have right operational integrity to right give them what they want uh, consistently right over time. Delivery. Well, do we meet our customers' right time frame? So from order to delivery, are we hitting the mark? Right, and right, does the customer perceive us as providing value? So for all these, right, and these are just four, and there can be right a dozen. Right, what is it uh, that is important to the customer? And then how do we know that we're meeting their expectation? So this is the whole part of gathering that voice of the customer and trying to turn that into what is really critical to quality, critical to meeting their expectations. And so not all of these are perhaps equal, and the idea is we're going to come up with a hierarchical uh, list of customer expectations, what they want, and then how we are going to provide and satisfy what we call the wants and needs right of the customer. So to answer the first question, who are our customers? Um, right, we may or may not sort of know the whole breadth of who it is that we serve. So we can look at it in a couple different ways. There's a lot of different segmentation methods. We just talk about a few of them here. So these are always, especially in the auto industry where I work, but we have external customers. So we deliver to dealerships and to the customer that pays for a vehicle. But then we also have these government agencies. So, right, Department of Transportation tells you, right, what a tire must do, right? The EPA tells us how many miles per gallon and how many, right, units of carbon, right, a vehicle can produce. So when we look at a project, which of these customers are we trying to satisfy? So is it the person that pays the bills? Is it right a regulatory agency that we have to satisfy? Maybe both. And then if you're not the producer of the end item, right, you work someplace in this supply system. Well, who do you deliver things to, right? So these could be internal customers. So it could be one department that hands off to the next. It could be one supplier that hands off to the next that's going to continue with the value-added activity till you finally get to the manufacturer that delivers something to the customer. So these are some easy ways to look at who might we try to satisfy. We can also look at big customers versus small customers from dollar value or volumes. And right, is this project trying to satisfy them all, or are we trying to look at a particular customer group that we feel might be underserved or unsatisfied with our performance? So any process that we try to improve is part of a bigger value chain, and we talk a lot about value-added activities. in our processes. But if you look at any very halfway complicated product, right, there's a chain of suppliers, and I call it kind of from dirt to product. So there's the very rawest of raw materials, and then we continue to add value. We continue to do assembly processes until we finally deliver something to an external customer. And so part of the definition, part of scoping is, well, which part of the value chain am I going to work on? And then focus there before we would expand into other parts of the chain. So sometimes a project might be at the interface, so it might be working with your upstream supplier together with your first steps in your process to make that flow smoothly. It might be at the end of your process where you're working with the next person in the value chain to make sure that what you deliver is what they need to further process things for their external customer. Or it might just be within your four walls. And we're going to define that with that very high level process flow. So it's important to know where we work in the value chain. We might eventually improve the value chain from beginning to end, but typically we're going to do it through a series of organized improvement efforts in order to make it go fast and for it to be successful. So what is a critical to quality characteristic? So these are those things that our customers expect from the delivered product or service, and it's our job to decide for this particular project which ones are we going to address. Hopefully, because currently our customer is not real happy with our delivery of one or more of these characteristics. So we have them broken down here. Again, this is hardly a complete list, but you can certainly think about a customer and how they might judge your output as being good or bad based on some of these factors. So on the product side, its performance, the different features, timeliness of getting an order to them. Hey, reliability. I work a lot in the reliability side of the business. Does it break? So serviceability, durability go together with that. Hey, you have a good reputation in the marketplace. On the service side, again, find the market. Are you responsive? So when the customer needs you, are you there? Reputation, credibility, going together. In some service industries, I work with Verizon. So hey, network security. Are you keeping people from stealing my data? The understanding, if you're providing services to the business, how well do you understand their business, and how are you making their business work better? So one or more of these different critical to quality characteristics are going to be somewhere in your project. And the key, as we'll show on the next slide, is, well, which one are we going to work on, and how are we going to measure where we are today, where we'd like to be, and then paint that gap in performance. So for addressing voice of the customer, we saw those three voices on our little chart in the last section, is part of the project objective, part of the business objective. We really need to look at these three steps. Who are the customers? So we can list them, we can segment them, we can prioritize them. Maybe we're working on, well, hey, if these three customers pay 80% of the bills, maybe we want those three customers to be the happiest. But which customer segment are we going after? So we start there. Well, what do they want, right? So we're going to look at those critical to quality uh, characteristics and hopefully determine one or two where we're not meeting expectations. So maybe we're not really good at timely delivery. Maybe we're not really good at a quality aspect or reliability aspect, and we can try to close that gap. And then mutually, in order for the customer to say that we did a good job, we should mutually understand, well, what's the measure of success? And if we're doing this on their behalf, would the customer agree that if we move this characteristic from this level to this level, that we in turn did get better? So they're not all created equal. We might prioritize one characteristic over another. And what we really want is how we're going to measure. What's the requirement? If it's speed to market, well, how fast is fast? And all of these move. So, when I was originally looking at shipping things, it got shipped on time. Today with Amazon, maybe it needs to be shipped and delivered right on the same day. So, what is the requirement so that we can make sure the process is designed to meet that? So confirmation that the customer nods their head that if we could get to this performance level, that they would be happy. Right. So the other side of the coin, not meeting a customer expectation has a cost, and or not meeting a business expectation or an employee expectation has a cost, and we call that cost of poor quality or COPQ. So let's look at a couple aspects of cost of poor quality, which will be the financial part or the business reason for uh, going forward with a project. And we'll measure our impact on this cost of poor quality both at the beginning and the end of the project. So it looks like I gave it all away on the last slide. So, just to look here, that's one of your jobs as project lead will be to estimate what the current cost of poor quality is. This will be a driver for why the project exists and why it should move forward. And we will learn more as we go through the projects, especially in the measure phase. Is our calculation correct? So how big is our gap? We're going to know that when we get out of measure, and we'll be able to substantiate what the cost of poor quality is in the current state of the process. So COPQ is going to represent the financial opportunity, bigger financial opportunity, the higher the project's going to rise up on the list to be executed by you as a project lead and the team of resources needed to execute that. Where do we start for cost of poor quality? Some of the obvious. Hey, defects costs money. It may be hard to tell the total cost, but we know some of the rework, scrap costs, those types of things. Some of the tougher ones are when I have an escaping defect and now I have a warranty cost or some customer dissatisfaction where I might lose that customer over the fact that I had a defect. How do I prevent defects, So I'm going to do inspections and appraisals, and I'm going to have decision points. Those all cost money. So if I'm going to measure things, there's a cost for that measurement, and then there's a cost for making it go down a good path or a bad path to be reworked. So those are some of the things that are kind of core from where did this come from right, in the first place. The other thing we have on here is that, right, it's a symptom. It's not a defect itself, right? It's something we're going to try to quantify as the reason that our process is not optimum is because we have these costs due to quality not being what the customer expects. Right, so some of the more obvious, sometimes we call these the above the line costs. So scrap and rework, right? These appraisal costs, right? Some of my favorites in my old military days, inventory that we lock up in a cage, and then on Friday afternoons we decide what to do and disposition it. External, right? Warranty costs, right? How do we keep our customers happy? We send them a sales guy, we give them a discount, right? All those types of things. And then, right, those all add up to, right, we have a whole uh, sort of department that does nothing but try to keep the customers happy. And if we could really be in this Six Sigma 3.4 defects per million, how much smaller might all of these things actually be? We're going to talk about how do we do prevention so that we don't have some of these costs, but right, mistake proofing, right, making sure our suppliers, right, we quantify that they're giving us what we want, designing in goodness into the product, and then right, how do we detect, right? So we do right, send people to the suppliers, make sure that they're measuring things correctly. Oh, yeah, I used to do this. You don't want to get in that game, right? Sorting incoming parts. We're going to use these. We're going to send the other ones back. So these are typically what we call sort of the above the line costs that we can go out and usually pretty, um, you know, roundabout way quantify in some uh, respect. So it's definitely scrap, right? If we bought it for this much and we get this much in reclaim, right, we know what the actual cost of scrap is, right? If we have to uh, have a certain amount of inventory that is unavailable, right? We know how much right inventory is and how much it costs to carry that. I know, right, in part of my job, every week what we spend on warranty costs to pay for parts and labor to fix things. So we usually have a pretty good handle on some of the costs associated with these above the line type elements. All right, so here's our COPQ Iceberg. I've seen a lot of different versions of this over the years. But again, the ones we talked about on the last slide are the more obvious. But then there's right some of these that are a little less obvious, and I like some of these down here. Well, what if we used to call it in the telephone industry? What if a customer churns, right? They go they go buy their product from somebody else. Well, those are expensive. Right, when we took about look at the profitability of a single customer right over a lifetime, and you lose that, well, then you've lost all that buying into the future. And I can tell you in the telephone industry, we determined it was somewhere around customer acquisition cost was about 2 years worth of service. So you can imagine you pay your cell phone bill every month, right? Kind of giving away that for free just to get one more right customer right into the stable. Right, time value of money. I had some really good accountants over the years on some of my projects on. Well, hey, if you get the inventory down by this much, this is how much you're gonna save. Uh, Sometimes we know expedited costs, but I've worked in the aerospace industry where we've put jet engine parts in a first class seat and sent them to some airport someplace, right, in order to keep an airline going. Right, some rework costs in different departments. So maybe we need a change order in order to deliver something to a customer. So there's a lot of things both above and below the line, and one of your tasks is to think about in the process that you're going to go try to improve, which things do we know and not know, and maybe you can't quantify some of these, but you can at least talk to the fact that hey, if we don't get better here, right, we're going to lose customers, right, we are going to have right overtime costs to meet customers' needs, etc., etc. All right, so some of the costs are more easily uh, quantified, right? We call those the more hard savings. We'll actually put that into the COPQ calculation. On the other side, I've seen it a few times if that's really the focus of the effort. But we can certainly talk to these things, right? Getting a customer for life, missed sales opportunities because we didn't either have the capacity or the quality level to right get to the next place, uh, right? Preventing regulatory right failures. So right if regulatory agency decides you're not meeting right the minimum requirements, well, hey, that's going to shut the whole system down until they're right satisfied again. So some of these right are game changers if you don't meet them. But typically when we talk about project cost savings, it's over here on the things that we can really quantify in dollars or hours or customer satisfaction levels. All right, so while the subject is fresh in your mind, hey, take a few minutes and identify cost of poor quality opportunities, right, either in your current right area of responsibility or for the project maybe that you've already been assigned to work through. So use the previous slides to help you. Look at the iceberg and some of the slides before that for the different categories, and just brainstorm a list of some of the COPQ opportunities that you think you could address by a current or a future project. So spend a few minutes on that. Go ahead and pause the recording, write a few things down, and then keep those with you. We're going to continue to build on your process flow and your COPQ opportunities as we build a charter and launch an actual project. All right, so pause the recording now and write down a few COPQ opportunities. All right, so now that you've got some COPQ opportunities in your mind, let's move into how we might measure things on a particular project. And we've already talked about sigma quality levels and yields, parts per million defective. So let's take a look at different aspects we might measure as process outputs. I've always liked these three dimensions for improvement, that you may work on one or all three at the same time. Some will say you can have any two out of the three, but not the third one. You got to pay for something. But I really believe that you can get and move all three in the better direction. So we talk about better, faster, cheaper. So on the better side, we talk about defects. So how are we failing to meet customer expectations? And some measures we have there are, let's count up the defects. So we can talk about defects per unit or defects per opportunity to make defects. So something normalized with the complexity of the product or process, and roll throughput yield. So the whole idea of, if I have a string of Six Sigma processes, my yield to my customer is still going to be quite high. So these are some measures, one or all of which we might consider in the better or the defect column. In most transactional processes, we're looking for how fast can we do something. So how fast can I process that mortgage application, right? How fast can I get a quote out to my customer? So we're usually measuring things in terms of time. So what's the start of the stopwatch? When does the stopwatch get clicked off? Can I improve that time? And then finally, cheaper. Hey, that's all the COPQ stuff, right? So if I could get rid of those costs of poor quality, right, I can then fold that back into my profit margin for that particular product or service. So let's look at some definitions further for each of the categories. So in the faster category, I can use this on every project. How long does it take, so cycle time, to get to the end? So I start, I turn on the stopwatch, I do my activities, hopefully mostly value added, but there might be some rework in there. So how long does it take to get from beginning to the end? And I always want it faster. So that can always be a project activity. How do I decrease the time to get from the beginning to the end in the process? In the better category, I typically talk about defects. And we usually make a distinction here on how you're going to count the defects. If I'm going to count up all the defects, right, maybe I have different kinds of defects. I have scratches, I have pits, I have breaks. So I have a different number of categories. Then I'm just going to divide them by the number of things that I produce, the number of units. Right, we're talking in the defect per unit um, world. That's typically where we want to be because we can address all of those. If I don't have that breakdown and I just know whether or not I shipped it or I didn't ship it, right, as long as it has one defect, I am going to not ship it. So if it's either a 0 or a 1, we call that, right, it's defective or it's not defective. So we do differentiate between, I can count a whole bunch of different kinds of defects in a single unit, unit of production, or I simply just know whether it was good or bad at the end of the production line. I shipped it or I did not. And then our unit is always whatever the unit of measure is, usually the thing that we deliver to, right, the customer. So to show you, right, with a little block down here, if I'm measuring defectives, well, I just know that it had more than one defect. So this unit is defective. But if I go to defects per unit, yes, it's defective, but I know that it has two defects. And so I can say it has two defects per unit. So typically it's a little bit more granular. I can see more into not only that it's bad, but how many things are bad in that particular unit. All right. Well, I hope not too many people are in this first time yield world anymore, but right in the past, it was always good if you started with 100 things and 100 things came out. And again, what we said was we usually lost the cost of poor quality because of all the different rework that might have happened along the way. But somehow, some way, we moved things inside the spec limits through further processing, through finessing, and we got 100 things out of the end. So here we're showing a golf club manufacturer, and right, it's a very simple process where we've got your grips, your shafts, and then we attach the club head, and somehow, right, if they start with 100 units of input material, so 100 grips, 100 shafts, 100 club heads, they can get 100 out. But hey, along the way, we had to fix right, 40 of the grips. We fixed 30 of the shafts, and we fixed, right, 20 of the club heads. Now, based on first time yield, 100 in equals 100 out, we're perfect. We're awesome, right? We didn't scrap anything. We didn't throw anything away. But our cost of poor quality is really down here. Well, how much did it take to, right, repair these particular grips? How much did it take to repair the shafts so they could be usable? What did it take to repair the club head to make the final club? So, right, the idea that I didn't scrap anything is not always the best way to look at performance. And I have an actual work example where I was working with a master cylinder manufacturer over in the west side of Michigan, near the lake, and it was a foundry, and I didn't know a whole lot about pouring metal and sand casts and all that kind of stuff at the time, but I walked in there, and in the middle of the factory, there's this mountain of master cylinders, and I'm like, okay, well, this doesn't take a real consultant to figure out that's not good. And but I did. I went and talked to the plant manager, and they said, well, we just remelt them. So right, there's never anything that escapes from the plant. So all the metal in equals all the metal out, and therefore, right, I have 100% first time yield. So I'm really happy. And I said, okay, well, I got to take a different approach. So I went to the accounting team and I talked to the head guy that did the numbers for the plant, and I said, "How much does it cost to get one of those like little master cylinder bodies to that point, right? Because we paid to melt it, we paid to cast it, right, and then we threw it in that pile." And he finally came up and said, "Yeah, we figure it's about $6 of right labor that got put into that to get it to that state." Well, now it's a whole different story. So I've got a mountain times $6, right, which added it up to tens of thousands of dollars per month that right was happening over here. Yet if you looked at right, the plant had no scrap. So if you measure it this way, everything was great. Right? If you measured it the way I was looking at it, hey, we had a lot of rework that we were paying for that we needed to recapture into the process. All right. So in DMAIC, Six Sigma, my favorites, right, are this idea of rolled throughput yield, and the reason we have six in our Sigma quality level, right, is we want each step to have the highest yield possible. So if I look at it more from what's the chance that I got a golf club out the other side without having to be touched with rework, we get a whole different story. So I have a 60% yield here at preparing my grips. I have a 70% chance of having right defect-free shafts, and I have an 80% chance of having right defect-free heads. Well, the chance that the club that was produced that never got touched with a rework cycle is what we call rolled throughput yield. So I'm going to measure the 60% times the 70% times the 80%, right, which turns out to be 34%. So in reality, and this is why we say this is a good, better type of statistic to use, is that my rework free units are only 34 out of 100. And so my opportunity then is right the opposite right of that, or the 66 units that had to right have rework along the way. So we say this is a much better way to look at yield. I have a current project that I'm working on with parts deliveries. And right, you can see how the rolled throughput yield, right, we miss somewheres in the middle, right? So I go to my part delivery people, and they keep telling me when I push parts out into the system, I have a 90+% what they call fill rate. I get 92%, 90% of what I say I'm going to get right out into the supply chain. But then when I look at it from a repair perspective, and I need 4 parts to do a repair, and each one only has a 90% chance of success, right? 9 times 9 is 0.81, 0.81 times 0.81, 0.64. Right, I only have a 64% chance of making my customer happy that they're going to get all 4 of the parts that they need right at the same time. So, right, when I look at it from their perspective, hey, I'm great, I'm delivering 90%. When I look at it from my customer's perspective, we're not so good because they only get right 64% of the time get all their parts. So, right, we need to right bridge that gap of the idea of yield versus rolled throughput yield from a customer perspective. All right, finally, a little trick that we can use sometimes. We're going to show it in this example. You can mix and match DPUs and defectives when we have very low defect rates. And so in the top, we're going to show you that we can just add the defects per unit and switch over to yield. And that's a very handy, right? Doing addition is much easier than doing a multiplication of yields. So on the top one, we've got our defects per unit, right? The translation of the yield, right? We add them up, and we come up with 1/10 of a defect per unit. So a very low defect rate. And then we use one of our favorite equations. The yield is equal to e to the minus defects per unit. So e to the minus 0.1 is 90%. And lo and behold, I get the same answer adding up the DPUs as I do cross multiplying the yield. So 95 times 99 times 96 also gets me 90%. So when I'm in the low, right, whether this is defects per unit or right defectives, I can just add them up, use my little e to the minus DPU, right? It's EXP in Excel, or right, usually the E function on your calculator. Right, it doesn't matter which way you do it, you'll get the same result. For higher defect levels, right, we always have to convert over to a yield, and we're going to show you that on the next slide. So, hey, in this case, it probably doesn't matter whether you say you have an 8% yield or a 3% yield; it's still terrible. But from a pure accuracy perspective, if I add up a half, 1, 2, I have 2.5 defects per unit. If I use my little e to the minus DPU, I get 8%. And right, versus if I cross multiply my yields, 60% times 36% times 13.5 gets me to 3. So if you're really in the small ones, you can add them together. If you have any doubt, it's always okay to cross multiply yields. So if I know the yield of this step is 95, this one's 99, this one's 96, right, this is always the correct way to do it. It's just that if I know them in DPUs, it's nice to just add them together. But why does it work sometimes and not others, right? And for completeness, right, we've got that on the next slide. Right. So usually we don't try to get too wonky with you, but for completeness, what's the difference between defects per unit and defectives? Well, they come from two different distributions, and so those that are familiar with the binomial distribution, right, it can have a pass or a fail. Uh, right, bi means it only has two states, and so here we look at 90%, 78%, 61%, 37% yields. Well, it's right 9 goods, 10 bads. It's 78 goods, 22 bads. 61 goods, 39 bads, and right now we're starting to go the other direction. I got um, 63% bad ones and 37% good ones. On the other side of the coin, if I have defects per unit, uh, it has a distribution that skews out to the right, where the DPU is actually the mean of the distribution. Now, for low levels, wow, those two distributions look the same. There's only this little sliver where I've actually got 2 defects per unit, and right at about the 10% range, it's not enough to make any difference. So you can see the two distributions right until you're hitting 20-25%. They really are giving you the same answer. So it would be inappropriate if I had one process that had, 1 defect per unit, one process that had 3 defects per unit, another process that had 5 defects per unit, to try to make pretend that that distribution looks like that one, because they really don't. And you can see that they start to deviate. So the bottom line is, hey, you can never go wrong if you cross multiply the yield of this step plus or times the yield of this step times the yield of that step. So you'll always get the right answer in that direction. Sometimes when you're doing a process mapping activity and you do have low defect rates, it's just kind of fun to just add them together rather than do the cross multiplication. So just know that the changeover point is somewhere in here where you have to have pretty low uh, defects per unit in order for the two to match up. So here you got 75% yield, a quarter of a defect per unit, right? There's some small piece you can see here that's got 2 defects per unit where we only really allow one. And then it really starts to deviate pretty quick after that. So just for completeness, right? Don't sweat it. But 2 different distributions: defects per unit, Poisson; defectives, Binomial. And we will further look at how we use the characteristics of those distributions when we get further into hypothesis testing. But here we're just looking for, hey, what's the yield of the overall process? And we don't want to look in terms of first time yield like we showed with the golf clubs, 100 in, 100 out. Right. So as we continue to venture into the define phase and some of our background material, in this section we looked at a high level process map. What's the left boundary? What's the right boundary? What are some high level steps that turns my input into the output? Where am I going to get value for the project? Right, this whole idea of COPQ, cost of poor quality. Then we looked into, hey, am I going to measure faster, better, or cheaper? And some ways we might do that. The last couple slides got into the idea of defects per unit versus defectives. And then finally, the difference between this sort of nonsensical first time yield, did I scrap anything or not, versus did I really get a defect free unit all the way through my process. And then the body of knowledge elements that match these, I can now define a high level process, talk about critical to quality characteristics, how those translate into cost of poor quality, and then these basic Six Sigma metrics are the ones we talk about over here. In this section, we are going to talk about project selection. In this project selection section, we're going to talk about business cases as part of the project charter, Pareto analysis to help us to scope the projects, metrics, what are going to be our primary and secondary metrics, and right back into the business case. What do we consider to be the COPQ that we might capture as a result of the project? So where do projects come from? Where are we going to find our different project ideas? And we kind of show you a crossroads here, and really you're going to probably use all of these different approaches. We're going to try to point you down here on the bottom to a structured approach. But really, they'll come from all three sources, right? Some projects are blatantly obvious. Hey, I have a problem. My customer's not happy. Right, I need to do something about it. I missed my financial targets for some financial line in the business. Those are going to be ones that are going to make it onto the list. There's a brainstorming approach. If right, our hopper is pretty empty. We can get all the people in a room, and we can think of, well, what are some project ideas? But what would like to take you through in the next few slides is putting some structure to selecting projects. Certainly, we can start with brainstorming. We can add in some of the blatantly obvious, but we'd really like to make sure that from a return on investment standpoint, we're working on the projects that are going to give us the best bang for our buck and the resources that we're going to expend. As we go through the slides in this section, we're going to be building up to what we would consider to be the sort of the defensible words and documents that would exist in order to move a project forward. So typically we would start with a business case, and we say here it answers two primary questions. What's the business motivation for considering the project? So which of the voices does it address? What are some of the COPQ items? And then where does it live? So in which business function, which business area does the project at least start in? And then we can cross over into multiple areas if required. The charter, that's going to be the actual document we put together that really launches the product once it's approved. We may develop many charters and select the best of those charters. I've done some consulting work at various companies where maybe we put 30 charters together so that they could have a good project hopper to assign to their different belts. So we're going to take that business case, we're going to roll it into a charter, we put some more detail together, and we're going to show you all the different elements of that charter. And then finally, it's the show me the money. So if I did this and I made the improvement, what is the business benefit? So they kind of all wrap together to make sure that we have a good solid foundation before we launch the project. This is a general look at who is responsible for each one of those three pieces to launching a project. So the business case typically comes somewhere in the management structure. There should be somebody that is asking, hey, I need some help because one of my voices is complaining, right? My customer isn't happy. My financials or my yields aren't what they should be. Maybe we did an employee survey and we want to get employee engagement up. So typically the business case originates somewhere in the management structure. That doesn't mean that they don't come down and pull in masters and belts to help form them, but really sponsorship should come from the business level. When we talk about the charter, that typically falls on you, the process lead. Now it's really just to fill it out, make sure all the elements are there. You're definitely going to have to reach down for the financial part of it to your finance leads, and for wrapping the business case, right? That should have already been done up here at this level. And then the benefit analysis, again, depending on what the savings amount is going to be, it's always nice to have somebody in finance check over your numbers. They can always come up with some maybe additional places where savings can come from. I know many times when I've done a project, I might be just looking at, hey, I'm going to save this many hours by streamlining the process, and they'll come back and say, oh yeah, but you saved inventory too, and hey, the extra throughput gave us extra sales opportunities. So it's always good to have them check off on it. From a update, we say the charter, right, is a living document. We'll probably only update it at each toll gate, but if we make a change to scope or a change in direction, right, we go back and we change that. The benefits analysis, we're certainly going to confirm it in the measure phase. We'll talk about that more. As if the scope changes and things change, we might go back and revisit it. But typically, we take our first guess and define, we validate that in measure, and then we are going to right, put it into the cash register during control. So here we're saying that we might start with your current business dashboards, your key process indicators, call it right, the KPIs. Well, which ones aren't at the levels that we would like? So those make very good starting points for developing projects. So those might be any of the, all right, the things that are below. I have too many defects, it takes too long, I have some type of a revenue challenge, customer complaints. So there's the good old voice of the customer. There's that other customer compliance with government agencies, state agencies, and then finally safety. So, right, if we have unsafe workplace conditions, right, we might do a project to increase safety, things like down work days, OSHA recordable injuries. I've done quite a few of those in my career. So that would be at the first level, right? Then we're going to break those down into smaller chunks so that we have a manageable project that we can work on quickly and execute and get some results. So you'll see throughout the course, we'll talk about breaking things down into an actionable level. In the analyze phase, we'll talk about root cause analysis, and we're not really done until the root cause is at a level where we can do something with it. And the same thing is going to apply here for which business case are we going to go after with our project. And typically at the corporate level, right, or at the high division level, right, it's too big, right? We have to break it down into smaller chunks. So one that I have at my current job is right, the corporation wants so much free cash flow generated every quarter. Well, hey, that's a good goal, and we should measure that. But I don't know of a single project I can do that's going to have an impact on that going forward. So we have to kind of break that down. Well, what does that mean for the different product lines? What does that mean in the different functions? And finally, right, what processes do we have to execute more efficiently in order to make that happen? So any good project selection activity is going to be able to take something from the highest level and break it down to, well, what does that mean here in this process activity, and how much do I have to move that? And as I add those all up, then I can get to my level 1 objectives. Let's look at an example. Right? Our company may have determined that our material costs are too high. So, right, in a good old EBIT equation, we look at our revenue and we take away our costs, and we've determined, hey, that line is too big, and one of those contributors is material cost. Well, one way to break down material cost is we could break it into what we call uh, direct materials, so those things that go into a product. So we need those in order to uh, get our end good, and or indirect materials. So the things that help support the process, different fluids and grease and boxes and right anything that supports the process but does not get attached to the final unit to be delivered to the customer. So this might be how we break it down at the first level, and then we can keep going on the next slides to break it down even further. And so it kind of follows this idea of y is a function of x as we break this down. Right, we call this sometimes a focus tree or a tree diagram, but we're starting at a high level and we're going to try to break it down into this actionable level. So our material cost is a function of, right at this first level, direct materials and indirect materials. All right, so let's go down a couple more levels. If we decide that the direct materials is the biggest lever, it's the thing that we want to use uh, that we think is the most off target, we can break that down by commodity type. So maybe I have a procurement department that buys metals, steel and aluminum, and maybe another department that does injection molding and other plastic parts. And then I can break it down even one more level. So am I talking about right the scrap levels or the metal that's used in the product itself? And so here we've gone from material cost to direct materials to metals to scrap. And you can see we're getting honed in on something I can kind of wrap my arms around and come up with a project improvement idea. So again, down here our y is a function of x. We could have picked between metals and plastics. We picked metals. If I break metals down, right, we can say the metal that's used in the product or the scrap, the stuff that's left over after I've done my processing to make the product. So what's left over, what do I throw away? So then finally, we're going to get down to a process level. So when we look at scrap, and it's metal scrap, I've got two production lines. One does drilling, the other one does stamping and punching. And looking at the data, we decide that really we can get the most bang for our buck by going after the scrap from the punch press. And so now we've gone from a material cost, very high level, down to, hey, I think I can make an impact on the scrap that's generated at the punch press. You can see how much more clearly defined and more actionable that project is going to be than, hey, I want to take away material costs. So this is what we're talking about in a tree diagram, how we focus our project down to an actionable level. Let's start to put together an example business case. So again, the business case is giving you the business reason for putting the effort in for a project. And really, I like these three bullets here, right? So what's the measure that we are going to try to improve, and that should relate back to that top level KPI through our little tree. Where do we think we currently are? Where would we like to be? And we paint this gap, right? So we want to paint the gap in performance between where we are today and where it really needs to be in order for those voices to be satisfied, right? Our customer, the voice of the business, and the voice of the employee. So I'm always, I actually had a little logo in one of my companies that said "Close the gap." So So what is the gap in performance that the project is going to focus on? So this is a format to put together a business case, and you can see, right, it's not meant to be very complicated. It's not meant to be very wordy. It's really supposed to get at what is the performance measure we're interested in, and what is the gap in performance to uh, where we want it to be. So, just kind of breaking it down here. First, what's the time frame we're talking about? So we give the reader, hey, where did we get the data from that we computed these numbers from? So anybody could go back and recreate the information. So it's important to have sort of a base. Is it for a whole year? Is it for 6 months? Is it for past 10 years? In this case, we're saying during the past fiscal year, the first time call resolution efficiency for hardware setup was 89%. So this is some type of a call center. Uh, People purchase hardware and then they call in to help uh, get the hardware set up. And we have an 89% efficiency where we don't have to escalate the call to a higher uh, help desk in order to resolve the situation for the customer. All right, so at 89%, they want to be at 97%. So the gap in performance is about 8%. And they're saying they've done some benchmarking, looking out into the industry, how do call centers operate. They believe that we should be able to get up to about a 97% efficiency. So only 3 customers out of 100 have to be kicked up to a higher level in order to resolve their hardware setup issues. And then what's that worth? Well, hey, if I could have more level 1 operators and less level 2 operators, that would amount to about a $2 million savings annualized. So probably most of that estimate comes from the difference in the tiers of help. So your level 2s might actually be engineers or product people, and your level 1s, we've got a script, they might work in a phone bank, they might work offshore, and that delta probably comes from there. There's also that part below the line for the COPQ, little iceberg. Hey, customers are happier if they don't have to get bounced around from phone call to phone call. So there's some level of customer satisfaction that's kind of a bonus to that $2 million. So again, it's what is it we're going to, the metric, first time call resolution, where do we think we are today, where would we like to be, this paints that gap, and then what's it worth? So if I were to fix the gap, what do I get in terms of COPQ savings? So we include this little template for you so that you can fill in your own business case. And it's got the nice little fill in the blanks. And if you can fill them in, you probably are 90% there on the way to having a really good business case that we can then turn into a charter. We give you the opportunity to try to fill out this business case template. We've got the template recreated for you here. So think about the projects that you've been assigned or are thinking about doing, maybe a project you've done in the past, or at least start to think about, well, where would I get some of this information in order to be able to fill the template out? So take a few minutes and think about how you might put this together, what some of the challenges might be. And if you're able to fill it all the way out right now, I think it will help in the next sections where we put the project charter together as we go through the rest of the training. So the more you can have something in mind that you might be working on, the more meaning some of the next sections will have in terms of you being able to actually fill them out as we go through the training material. So go ahead and pause the video here and see how much of this template you might be able to fill out for a project. Well, welcome back. Hopefully you were able to put some elements of the business case together. And you'll see as we go through, a lot of things build off each other. So the next step is, hey, let's take that business case and build a charter. So, right, we're just going to roll in. Hey, we think this is an important thing to do. So how do we break it down and sort of put together a sort of project plan with the resources and the different elements we need in order to be successful. So these are going to be the components of the charter that we go through. So we're going to take that business case and make a problem statement from it. Right, what are the metrics? We're going to talk about scope. Right, we're going to talk about timeline and resource information, and then we will be all set to get approval and move forward with the project, at least from a chartering perspective. So let's look at some of the main elements in the charter. We're going to have a problem statement, which really just articulates that pain point that we've identified in the business case. An objective, one of my favorite parts, which really talks about the gap and paints what does success look like. Scope, we'll talk a lot about scope and some other tools we can help to scope. What is the metric that we're actually going to improve? Some other metrics that help keep us honest. And then right, we'll start to put together the charts of the primary and secondary metrics so we can get the baseline. And then as we make improvements, we should see the performance go up or down, whichever is the good level as we execute the project. Here we have the project charter template, and we're going to start by putting the business case into and converting it into a problem statement, or in this case, we just lifted and shifted. So this template we do provide you, it's called, fancily enough, Project Charter .xlsx. So if you ever want to follow along, and we'll have you open it up and try to fill in some of the sections later as part of an exercise. So you can see right here we've got the problem statement. Really, it's just the same as the business case. We've got the year 2005. We've got the baseline first call resolution for hardware setup at 89%. We include the gap of 8%, the sort of the best in class at 97%, and then our savings at $2 million. So we're off and running. The business case, all we did is lift and shift that into the problem statement. All right, then my favorite part of the charter, the one I focus on the most, the project objective, and then we'll talk a little bit about scope as well. So first, we want to look at what is the one metric, not the 15 or the 12. So we do want to settle on a particular metric that we would like to improve. We may have other ones that we're concerned about, and we'll talk about adding them as secondary metrics. But it's much easier to focus a project to move a particular number right up or down the scale, whichever one is in the better direction. And then the other piece of it is how far would we like to go? So how much of the gap would we like to close? So I really like this format. I'm going to improve my metric Y from the current level to some desired level by a date. So whatever the project end time that you've projected, and we'll put that in part of the project plan in the charter as well. So here's an example. I'm going to improve my process cycle time from 21 days to less than 10 days by October 2024. So I know when I'm done. If I hit 10 days or less, the project is complete. And I know what my target is in terms of what is my outlook to how fast I can get from 21 days to 10 days as I execute the DMAIC methodology. Scope, we'll talk more about that as we go, but it also includes the focus tree or the project tree we talked about before. We want to work on a problem that's big enough to make a difference, but small enough that it doesn't take forever to execute. So some of the things we can look at is, well, maybe we fix it at one location versus all locations. Maybe we fix one product type versus all. Maybe we help one customer type versus them all. And just ways that we might narrow the breadth of our project so that we can execute it quickly, build momentum, and we can always add on other pieces as we go. Well, one of the favorite tools we have for helping to scope a project, and we can also use this in the tree analysis that we did before, is called the Pareto principle, and the tool is a Pareto chart. And it was very simply came out of a study that an economist, Wilfredo Pareto, did back in the early 1900s. And he observed that 80% of the wealth was held by 20% of the land owners. And so we call it the 80-20 rule. And it just so happens that it is prevalent in many situations, and hopefully if it's prevalent in your project, it will help to narrow your scopes. So examples, maybe 80% of your phone calls, your outbound calls go to only 20% of your customers. 20% of streets handle 80% of the traffic. So those are the ones that we want to maintain first. Those are the ones that we plow first. If you live in a snow country like I do, 80% of the meals come from 20% of the menu items. So do you want to have a really big menu if in fact you're going to make your money from just a few of the items? 20% of the newspaper has 80% of the news. The rest is ads and pictures. So we're going to use this idea that we can maybe get 80% of the way to our goal by only concentrating on 20% of the inputs or 20% of the defect types. Let's take a look at the chart itself. It's actually quite simple, but packs a lot of information. So it is a bar chart. It's a bar chart that's in the highest to lowest order. So each of our categories, here we've got them A, B, C, and D. We put the tallest one first, and then the second, and the third, and then the fourth. So the bars are in descending order. And then we have a cumulative line, which adds up the bars as we go from left to right. So here's just A by itself. I add A and B together, and I'm at this point. I add A, B, and C together, and I'm at this point. And then A, B, C, and D together, if those are the only four categories, will add up to 100%. And then the idea of using the chart is I'm going to start to the left, and I'm going to go over to the right until I hit 70, 80%. So in this case, if I focused on categories A and B, I could fix 80% of the problem, and I could ignore columns C and D temporarily, and perhaps they would go along for the ride, but they have very little leverage compared to the other two categories. So that's the Pareto principle in action. I'm going to leverage the fact that most of the problems come from categories A and B in this case. Also use the idea of the Pareto chart at multiple levels. So just like we did in the tree, going from left to right, we can start off with what, in this case, production line has the most defects, the ones we can might influence the most. Okay, well, it's production line number one. Then we can take number one and break it down, and we say that, hey, product A in production line one has the most defects. And then we can even go to a third level or a fourth level, whichever we might be able to break it down to. And it says that, hey, product part A, B, C, whatever that might be, is the highest, right? Inside product A, inside assembly line number one. So when we have this happen, we can say, hey, if I was to focus on the issues with part ABC, well, it by itself is 35% of all the defects, right? That's a good place to start. One fix gets me 35% of the way to zero defects. So in many cases, we can cascade the Pareto chart to get us to even more actionable level, just like we did with our tree diagrams earlier in this section. Now we're going to show you how to create a Pareto chart inside Sigma Excel. So I'm going to show you the screenshots here, and then in 2 slides we'll actually go live and show you the mechanics of actually doing this. All right, so first we're going to open up Sigma Excel. So if you don't have that done already, we can go ahead and do that. Once you have Sigma Excel open, or you can do it in the opposite order, we want to open up the file that has the Pareto chart data in it, Pareto.xlsx. And then once you have the data there, we're going to highlight it. And then these are the path to create the chart and get the dialog boxes. So first we're going to make sure we've got Sigma Excel open. We're going to go to Graphical Tools. Pareto's under Graphical Tools, and then the basic Pareto chart. Once you hit that, it's going to ask you what data you want. We're going to click that button, so that's almost always a next. Then this dialog box opens up. We're going to put in our X and our Y. So X is the line number, Y is the defects. We're going to hit next, and then that's going to bring us to this dialog where we can change to 100% or a different number of bars. All right, so let's take a look at the next slide of the at the output, and then we'll actually create the chart. So here is our results, and this looks like a good candidate that meets the Pareto principle. Like we showed in the 3-level chart, this is the same data. Production line 1 is up here, almost to the 80% line by itself. We could maybe add in 2. That's going to get us up above 90%. We can ignore production lines 3 and 4 for right now with regard to this particular defect type. So this meets our 80-20 rule. We may, what I would probably do is focus on production line 1 as it has the lion's share of the defects. So let's go ahead and show you how to um, push the right buttons to get a Pareto chart. So we have Sigma Excel open. You can tell that because we have the menu here for Sigma Excel and the chart tools. We have the Pareto file open. So you can see the data here in the window. I'm going to highlight the line and defects. So whenever you create a graph or a chart, Sigma Excel likes you to highlight the data that you're going to use. And then Pareto charts are under Graphical Tools, Basic Pareto Chart. And then it says, hey, what data do you want? So it already picks the highlighted. We do have data labels in the first row. So that's all good. All right, next it says which column has your X, which column has your Y. So X is going to be the production line, and Y is going to be the number of defects. All right, if you hit finish now, everything would work, but let's just show you a couple other options under next. All right, we've got the ability to change our 100% to something smaller. So again, if you had a whole bunch of categories, you might just want to see the first 80% or 50%. Or I like this option too. I just want to see the top 5 bars or the top 4 bars. We're going to leave everything the way that it was. And we're going to hit finish. And there we get our Pareto chart. All right, and so you can see you can cut and paste that right into PowerPoint or Word or any place else you'd like. It comes right up with the graph menu from Excel. You can change colors, you can change the format. But again, remember our Pareto chart. On the bottom, we have the line number in descending order, the number of defects, and then the cumulative chart here, which shows up here on the right-hand side. So that's how we create a simple Pareto chart inside Sigma Excel. Now, what happens if you're not successful? And I probably should have made this graphic stretch out a little bit more so it looked even flatter, but you can see our bars are all about at the same level. Each one adds an equal amount to the 100%. So if I get a chart that doesn't exhibit the 80-20 rule, okay, well, I don't have a way to focus based on the Pareto analysis. Now you can think of perhaps maybe there's a different way to slice the data. So maybe production line isn't a good way to slice it, but maybe product type is, or customer that we deliver to, or maybe it's shift, or maybe it's our supplied raw material. So since it's so easy to create the charts, if you have the data, go ahead and create a number of them to see if you can see the Pareto action in action where we can concentrate on one type of error and ignore the rest. Again, it's all going to help us with scoping our project, executing it quickly, and getting results. All right, so now that we have our business case, our objective, we've thought about scoping, right, it's time to enter in our primary metric. And in the template that we've given you, you can actually track it, not only right from maybe some historical period, but also you can track it as the project progresses. So it would be some, quantifiable measure that I can measure in different time periods. Again, we emphasize we want to have one primary that matches your objective statement per project. And right when we meet our goal, the project is complete. So now it will, if you put the goal in, it will give you a nice linear line to say, right, this is the way we would like to go to get there. In reality, it may not quite happen that way, but we're going to go in every month and plot the real point and see how progress is going as we execute the project. And right in reality, until we implement some type of a change in the process, we should not expect the output to change. So it's not going to just magically happen because we're doing the next phase in the DMAIC project. It will be in the improve phase where we start to execute some process changes before we might see the metric actually move in the desired direction. Also, in the template, we have a space for a secondary metric, and you can copy and paste and add as many secondary metrics as you think you should track. And the idea is that I'm going to keep the primary metric honest. So, for example, I might be able to produce more units per week, uh, but I could do it simply by adding overtime. So I might see the primary metric of units per week go up, but if I track the number of overtime hours, they would go in the wrong direction. So secondary metrics are there to keep the primary honest. Now, in some cases, right, if we were looking at like the faster, better, cheaper types of metrics, and I wanted to track all three, well, we might hit a home run, and all of them might move in the same direction, in the good direction, as we execute the project. But we're going to be happy if we move the primary metric towards our objective goal, and the other ones at least stay stable and flat. If they move to be better also, that's just a bonus. All right, so now we put it all together. We've got our problem statement here that we got from our business case. We put our objective and our scope over here in this section. We started to plot our primary and secondary metrics. So the last couple pieces, well, when would we like the project to be complete? So we'll put a simple, again, the main process, very simple, 5 milestones, 5 toll gates. So how would we like to divide up our time in order to meet the end date that we have in mind? So it's not bad to just start off and say, if I want to have this done in 4 weeks, right, we're going to spend a week in each phase. Maybe I need a little more time. Maybe it's going to take a few months. And again, I can divide up the define, measure, analyze, improve, and control timing to match that end goal. And then finally, what are the resources? Who are the resources? You are going to be the project lead. We put in the sponsor and also our subject matter experts that are going to help us along the way. Now you can also have what we call ad hoc team members. So not everybody all the time, but if you need an IT resource occasionally, you can invite them. If you need a finance resource occasionally, you can invite them, but they might not be part of your core team. So we're going to start off here with who are the core folks that are going to work day by day, week by week through the project with you in order to execute the project through the DMAIC process. So now we're going to give you some time to think about the project charter and if you're able to go ahead and start filling it out. So go to the project charter template, projectcharter.xlsx. It is not necessarily part of Sigma Excel, but if you have Sigma Excel open, you should be able to open the project charter template as a new workbook. And it's got all the different aspects to go in there and see how to change your metrics inside the template. We're going to cut and paste our goals and objectives. Here's where our team members go. Here's where the project timing is located. So familiarize yourself with the template, and to the best of your ability, go ahead and fill it out, and then you'll have that ready to roll as we continue through the course. So go ahead and pause the video here, explore the template, and see how much of it you might be able to complete at this time. All right, so now it's time to add in some financials to right, give the charter third dimension. What's the COPQ value of doing the work? So think back to what we wrote down as an objective. If we were to accomplish that, where would the value come from? And so when we look at the next few slides, we're going to talk about is the impact one that's going to last forever, or does it have just a one-off component? I'll talk about some of mine where we increased cash flow, or maybe it has both. Maybe it has a immediate little step change, and then we were able to have a year-over-year savings as well. So right, those are always good. To where will the cost come out of or get added to if we have a revenue increaser? So who's going to see the impact? And then finally, when is it going to happen? So is it going to happen in Q1, Q2, Q4? And we always look at when I've completed the project is when I'm going to start to realize the savings. If I can realize them sooner, hey, even better. And you'll know that by your primary metric. As it starts to move, you're actually going to start to realize some of your savings. And so we also say here's a good time to get somebody from finance involved to have some discussions about how you might calculate the savings from fixing some of the cost of poor quality elements. All right, so here we just have it sort of organized in a little tree for you. So again, is the impact going to be each and every month for ever and ever? So if I take, say, 10 hours out of the process flow, and those 10 hours are labor that I save, as long as the process can run that way forever, I always have that 10 hours of savings. Right, some of our one-off impacts. The one that comes to my mind is cash flow. If I can bring in some deadbeat people that owe me money, and I can come up with a project that brings them forward, and now I've collected that cash. Right, I've now had a cash impact in that particular quarter or month. And then it's going to kind of just roll forward from that point. But hey, these are great projects as well. And maybe you'll have some that have both. Then we say, well, where does it actually come from? So is it a cost reduction? Do I get more sales? Hey, that's great. Is there some either capital investment that I have to make in order for the change to happen, which again, that's sort of a one-time, or do I get capital savings for this year that I can roll into something else? So an example would be if I can get more throughput from my current production line and I don't have to double or triple it, right? I don't have to expend that capital this year. All right, and then sort of the realization schedule. When can I count the money? Again, typically it'll be towards the improved control phase of the project. But this is another good point to look at scale and scope. The faster I can get to savings, the quicker that they're going to get rolled back into the business. So if I can do a smaller project and start to get savings in the second quarter, and then do the next one and have savings in the fourth quarter, well, I've already got you know, 2-3 months or 2 or 3 quarters of savings, and now I'm on to my third project already. Whereas if I did a really big project, maybe the savings wouldn't come until the second or third quarter next year. So I've spent all that time without getting those incremental savings along the way. All right, so we're going to have some savings, and we want to know when the savings are going to appear, and that goes along with the project schedule. All right, so just a little sense check here. Again, our savings are going to be tied to right a higher level business imperative, like the one we showed with material cost savings. Our project might have been the punch press scrap rate, but as I save money there, that is going to trickle back up to the overall material costs for the company. So as long as we did our tree diagram or we use the Pareto analysis to get down to the actionable level, right, we should be safe there. We want to set realistic goals. Again, the faster I can get to the goal, the faster I can get to some savings. You never want to necessarily on your first project say I'm going to close 100% of the gap, especially if you're at sort of a 50% yield right now. You're not going to get to 100% yield in that first project. As far as right putting a value on project and the project portfolio, most companies do an annualized benefit. So even if the benefit comes in the fourth quarter, right, we would say over a year, this project would save this much. When I worked for the federal government, they had a 7-year budget POM cycle, they called it. And hey, they already had the template. We filled it in. Right, you could see what the project was worth across that whole 7-year period with inflation and right everything else baked in. But that's the way they did business. Right, that's the way we put it in to their system. And then make sure we've got the finance folks involved. We don't want to ever get crossed up in stating financials against rules for reporting. So, right, typically projects are going to roll up to the separate accounting rules for how we're going to do profit loss and all those good things, but we never want to get right outside of those with our projects. So in this slide, we're trying to put together, you might have some really good A projects. I think you're going to have a portfolio across all of these different types. I guess this is kind of stating the obvious. If I could find all kinds of projects that were going to impact, right, the income statement, right, either by higher revenue or lower cost, I would do those all day long, or right, getting my money faster or paying it out slower. So right, we're going to say right, those are going to give those a gold star, an A. Those that impact right working capital, where I don't have to expend capital, right, might be the next most desirable. Right then, cost avoidance. Hey, I see lots of these, and you know what? Eventually, these add up to that. So, if you right put enough pennies together, eventually you're going to impact your cost part of your income statement. And then, right, these might be the lowest in terms of can I put dollar amounts to them, but some of them would right put you out of business. So I have to meet my government controls. And right, I've done a lot of design projects where we had to meet an FAA requirement or a Department of Transportation requirement. Well, if you don't meet it, you don't get to make and sell the product. So we didn't get a lot of savings, but by executing the project, we were able to right move forward with the business. So just a different way to look at it. But obviously, if we can do things that are more the top and bottom line of an income or cash flow statement, those are the ones that are going to come and be executed first. All right, so our little roles and responsibilities chart here. So selecting projects, that comes from the business, right? We're trying to improve a certain KPI. Uh, the belt, is going to own the right DMAIC uh, process. When we get back to implementation, we're going to do a handoff back to the process owner, and then we're going to say, hey, we're going to go check every once in a while if everything's going well. And again, we want to might do that handoff, give that back to right the process owner. Right? You can see finance is sprinkled in here all the way across as part of the process. Uh, Pretty heavy up to define measure. Then, unless there's a big change, then they're going to come back in and be uh, more heavy in the control when we book the savings. And then in many companies and where I am today, we do an audit, especially for the bigger dollar projects, either 6 months or a year later. So we'll get the process owner, somebody from the DMAIC Black Belt team, and some finance folks, and we'll go through and make sure we're sustaining the gain uh, and right keeping the money. In our handy folder of templates, we do have a benefits calculation template that might give you some ideas of how to put the cost savings, the COPQ savings together. Certainly, you can use that if you have one that your finance folks like. Then use that. But keep it simple. If I can tell you, a lot of times I'll have people come to me and I just, don't know how to calculate the savings, and I'll say, well, what's our goal? Well, we think we can take, about 100 hours a month out of the workload by doing this project. We're going to write some macros. We're going to have better data that comes into the input. We're going to standardize the output templates. And I'm like, okay, well, shoot, $100 a month times 12 months, that's 1,200 hours times, like $100 an hour, $75 an hour, 125 an hour, whatever you want. Hey, that's some good dollars, right? So let's not get over calculated, right? We can put that in an Excel spreadsheet, 1,200 hours times, right, whatever rate we want to use, right? That's going to equal my savings. Now, if you have more dimensions, lots of little COPQ items, right, this template's going to help you to think about those and record them. The good news is if we do a good job here in define, right, validate that we've got the problem in measure. If we meet our objective, well, we should just have to review this when we get to control. So if we did our homework well, we're just going to say, yeah, we booked this savings when we meet our objective and get into the control phase. All right, so however your particular company works financials, right, that's the way that you should also look at the financials for a DMAIC project. All right, so here we are. We've gotten some of the basics of our projects together. And right, so we've looked at, hey, how might we go about selecting a project? And we talked about that tree or that focus tree to get from a high level business imperative down to an actionable part of the process that we could actually make improvement. Again, we're very process focused. What process are we going to make better in order to get our savings? We talked about refining the scope, right, using both that tree analysis to get down to the right y as a function of x level. Right, we can also use Pareto analysis. Also remember the high level process flow we did with the left and right boundary. So that's part of our scoping mechanism as well. We went through the elements of a project charter. We've given you a template. So hopefully now you can go as the belt, as the project lead, put that together with your sponsor, your champion, your process owner, and a little help from your finance guy. And right, they're going to help you with the initial finance calculations. All right, and these are the body of knowledge elements that support these support those, I guess you could say, the summary elements. So building the business case and the charter, how do you do a Pareto chart, project metrics, right? So we have our primary and secondary metrics, and then finally our financial capture of COPQ elements. All right, now we're going to cover our first lean topics. So we adopted some of the lean materials into Lean Six Sigma. So a little bit of combination of some of the DMAIC tools together with lean tools. And specifically in this section, we're going to cover what we call the 7 elements of waste and also workplace organization or the 5S tools. All right, so in the body of knowledge, we're going to cover just a little bit of what is lean, a little history, the combination of lean and Six Sigma. Again, the tools for the 7 elements of waste and 5S. Some definitions. I had the privilege of working with the author here, Barbara Wheat, when we did some consulting for Navistar International, their truck plants. And Barbara was our lean expert. We were the Six Sigma experts. And we figured out how to marry the two disciplines together. And it's sort of a natural fit. So when we look at the lean enterprise, the focus is that, hey, anywhere that there's work being done, there's waste being generated. And if we focus relentlessly on the elimination of waste, then everything will get better. So just a natural fit to Six Sigma, focusing on defects. And then when we look at lean and getting the flow and get rid of the waste, all kinds of good things can happen. So we're going to show you how we kind of incorporate some of the simpler lean concepts together into the DMAIC process as we work our projects. All right, so here we have a little historical timeline for lean, and it's typically tied to the automotive industry since it came from Toyota, right? And the idea of the Toyota production system, the machine that changed the world was a famous book that we used at Motorola in the day in order to incorporate the lean concepts into the Six Sigma methodology as well. So starts back right before pre-Henry Ford. Everything was made by skilled craftsmen. Really, everything was sort of a unique one-off masterpiece. So all the parts were cut and machined by hand, welded together, hand stitched. So even though there might have been a particular model or type that you could buy, if you went from one vehicle to another, there would be some differences because they were all built, pretty much from the ground up. Then old Henry shows up on the scene and says, "Hey, I think I can make this really cheap, and I can build a lot of them with less skilled labor if I break up the units of production with a moving production line and I make standard parts where every time I grab this part at this station, it's the same, and then I can change out the parts later on when things need to get fixed. So that was his contribution. The big rub was, well, you could get any car that you wanted as long as it was a Model T and it was black. So we experimented with some things along the line, but the next big innovation, at least from a lean perspective, was after World War II. Toyota was trying to bring back manufacturing to Japan, and they really had to overcome obstacles. They didn't have a lot of raw materials, and so they were just insanely focused on waste. We can't waste any of the materials that we're able to get our hands on. So everything has to be high quality. We can't have a lot of inventory. So they came up with the whole idea of the just-in-time manufacturing and really put some of the principles we're going to talk about in this section to work. Things took a while to get over to the U.S. So I was introduced to the lean concepts at Motorola. We read the machine that changed the world, but that was probably 1991, 92, and then it really started to take hold. And different companies, Danaher is one of the benchmarks in terms of, hey, they really grabbed it, held on to it, still use it to this day. But we can now apply lean not just to the Toyota production system. My second application was to the aerospace satellite industry. We actually built satellites on a car kind of production line. Totally shook up the folks that we were working with at the time, but we just gave them a book, said this is how we're going to build it, and we went off and we actually did it. So we now apply lean concepts not just to the auto industry, but to both manufacturing and transactional processes. So we're going to take the ingredients of both disciplines, mix them all up in a bowl, and come up with, as we say at the bottom, an extremely powerful combination of tools. So on the lead side, based on the Toyota operating system, that we want to get waste out of the system, relentless elimination of waste. Flow, and we're going to talk more about that as we go through, but it's all about creating flow and getting rid of the roadblocks that stop flow in the process, We want to continue to add value as we go from step to step in our process. So the big strength here, is efficiency. On the Six Sigma side, we're focused on our three voices: voice of the customer, voice of the business, voice of the employee. Data-based decision making, getting rid of variation, so variation waste, nice parallel there. We've got some analytical and statistical rigor, so again, that data-based decision making, and so our processes become very effective. So hey, that's a nice combination. We're efficient and effective, and that's why the tool sets work so nicely together. So now we're going to get into the elements of waste. So when we look at the lean side of your project, we're gonna search for waste. So anything other than the minimum amount of time, material, people, resources, space, energy to add value to the product or service, as we go step by step through the process. The Japanese word for waste is Muda, so sometimes you'll see the 7 elements of Muda. Sometimes you'll see the Japanese words. We've got them on one of the slides coming up. But the idea is that waste is the enemy, just like variation is the enemy, and we are going to be relentless and go after it. All right, so we say that we have to be able to see the waste, and believe me, you'll be able to see the waste in all your processes right after you've done a project or two, and we start to focus on where is the waste and how can we get rid of it. Right, so just what are these 7 elements of waste, components of waste? Waste or Muda. These are the 7 that will go into some details. So overproduction, correction or defects, rework, inventory or work in process, motion. So here we talk about it within the step, overprocessing, doing more than the customer wants or needs, conveyance, moving things between steps, and then waiting, which is usually a bad result of some of the other wastes. Some add in a couple of additional wastes, so the underutilization of your people. So if they're waiting, they're not right utilized to do good work. And then the addition of safety. So if we're not being safe in the workplace, then it doesn't really matter where our wastes are coming from. In your notes in the notes page, we include a couple of mnemonics, and so spell that a few times. One is Timwood, the other is Comwhip, and you can see right how we just rearrange the elements here to come up with that. Hey, how do I remember the 7 elements? Well, you can either use either of those, and there's probably a dozen others to try to remember, right, these 7 uh, concepts. But let's look at them in some detail. All right, let's start off at the top. Overproduction. Overproduction means producing more than the next step needs, right, or the customer can buy, right, in any time period. So we're just shoving stuff into the production environment, whether we need it or not. So we're kind of operating by schedule versus operating by demand. And boy, I've seen all of these in projects over my career. Extra reports. Uh, hey, we send out the report, but nobody seems to do anything with it. Multiple copies of data. So, what is the single source of the truth? I didn't know what it was until I heard this whole term of right the golden data or the keepers of the master data. That's the term, the master data, uh, and right whole teams of people that keep the data cleansed. Over ordering of materials, right duplicate efforts or reports. And I'll just give you one example. There's so many, but I was working with one of the furniture companies in the west side of Michigan, and they had a consultant come in, kind of like, they had us come in to do Lean and Six Sigma, and it was a Japanese company, and they made the equipment that cut out the laminate for your desks and your cabinets and your front of your drawers. So it was all cut from the same sheet, and so they came in and they had an optimization program that would cut out the most parts for a sheet of laminate, so you didn't have much waste. That sounds great, right? We're eliminating waste. Well, as you looked right down the production line through the plant, there were just stacks and stacks and stacks of these little circular tables that just happened to get thrown into the mix all the time because it didn't waste the laminate. And so we started to look at what was the demand for that particular little tabletop, and they had about 5 years worth of production readiness for that. So although they tried to do right lean in one hand, they were doing right really bad things in the realm of overproduction. Right, so we don't want to produce more than we can use at the next step. Well, I think correction is one of the more obvious wastes. At least we hope that it is. But when I create defects, I got to do something with them, right? I've got to fix them. I've got to sort them. So examples, right? I mess up that master data by putting some bad data into the mix, right? Something, right? Scrap or rework goes in. Right, I've got to sort or contain or somehow redo some steps to make the defect go away. So anything uh, where I'm fixing defects is a waste of correction. All right, so another Muda or waste, inventory. Well, how much inventory does it take to keep things running? So a lot of times we talk about the sea of inventory that makes up for the wastes in all of the other steps. So if I have lots of inventory between stations, well, the stations can't go idle because there's always something there to build because I've got this inventory uh, built up to hide all of my errors. All right. So anything that is sitting around not being processed is a waste of inventory. Another good example that kind of goes with overproduction. When I worked with Autolite spark plugs over in Ohio, we were talking about just consistency of input material. And they said, well, we buy all of our aluminum oxide by the trainload, and we just get one big dump per year. And I said, well, that's good and bad, right? That you have what you have. If it's a good lot, you can go for a whole year producing spark plugs without any issues. If you have a bad lot, though, well, you're stuck with that material for a whole year of production. And hey, that's inventory, right? You've sunk the cost of that raw material, and then it takes you a whole year to work it off. So inventory, we want to just go walk down the production line and say, right, how many pieces can I count up, and is that the minimum amount I need to keep production running? So the waste of motion. So typically we talk about two sort of movement waste. So this is the one that kind of happens within a step. So all the movements that you make as a person doing the task, right? The equipment makes, and we'll talk about how this ties in nicely with the 5S strategy we're going to talk about right next in this section. But how many times do I have to stop and go look for something? I need to find a tool, data entry steps. So in the transactional world, I always say, how many mouse clicks does it take to get to the information that you need? Another crazy one that I've seen is dual monitors where somebody's taking information from one system and putting it, hand jamming it into another system. And that was the best method that they could come up with because the two systems weren't compatible to just move the data over. So any motion that happens within a step, if you go to some of your like a computer manufacturer, I know Dell, and uh, they're really good at this. Right, if you look at how somebody packs a computer box, everything's at waste level, and you barely have to turn it all in order to stuff the box. Everything's right there for you to grab the box. The packing materials, the part, it's all right there. So they do a whole bunch of time and motion studies to figure out how to make it ergonomically correct and the minimum amount of time in order to do that particular step. So just think of that when we think about motion. Uh, what's sort of the internal motion of the step, and is there a lot of wasted uh, time looking for things, doing extra data entry, extra mouse clicks, etc. All right, our next in our 7 elements of waste, overprocessing. So overprocessing, right, any task or activity that does not add value. So if you think about making an invoice of the tasks that you do, and you're going to charge your customer line item by line item, would you feel good about putting that task on your invoice? Right. So some common overprocessing, right? Too many sign-offs. We're asking for approvals at the wrong levels, at too many levels. I can't tell you the number of projects I've done where we've been able to cut down the number of signatures from 7 to none, right? That the people didn't really need to look at the activities if they were under certain dollar thresholds or within certain boundaries. Communications that go on and on and on. So we always talk about bottom line up front. How do I make my communication short, sweet, to the point, without a whole bunch of extra right information? Because again, time is money. We don't want people to have to weed out and find the information that they need. And then one of my favorites, it's kind of silly, right? We have voicemails that are too long, but the good old reply to all, right? Especially when you have senior leaders and managers and the CEO in the chain. I always have to right laugh about that, right? We're stuffing up everybody's email box uh, by hitting that reply to all. So over processing, we're just looking for, is that task or that activity really required, and does it really add value to that customer? Waste of conveyance. This is moving things between steps, and we'll look at some improvements to flow. Are we moving things all over the place? And we used to call this staple yourself to an order. And sometimes we would find that a simple order of right going out into the warehouse, finding something, putting a couple things together, putting it in the box, and shipping it to the customer. Right, the poor part traveled several miles, getting from one place to the other. So, do we have things set up where the movement between steps is at a minimum? And or did we purposely put in movements that don't really need to be there? So extra steps right in the process. So they kind of go together with the waste of motion we talked before, but this one's usually reserved for moving things between steps. All right. So waiting is usually a fairly obvious waste, although usually it's not the cause. There's usually some other upstream cause that causes waiting. But waiting is any right non-productive time where we're going to be idle, a machine is going to be idle, a person is going to be idle due to right lack of material or the equipment itself being available. So, right, certain downtimes, the equipment breaks, we've got to call in maintenance, right, they've got to fix it, maybe they have to order a part, and right during that time period, we're not able to use the machine or do the steps that require that machine to be used. One of the ones that when I worked for a printing company, um, just the way that they did things very serially. When a production job ended, it was about a 4 to 6 hour uh, job to print the next you know magazine or newspaper. So they printed it on copper with a stylus. Then they had to change out the rollers, and then they had to rethread the paper through the machine. And so, we just asked the simple question, can any of that work be done ahead of time so we know what the next job is going to be? Can we get the rollers ready? Can we have everything printed? So the only thing we have to do is, swap out the rollers. And sure enough, we cut a 6 to 8 hour changeover down to about a 1 hour changeover from printing job to printing job. So they just kind of built the wait state into the process, not on purpose, but just right, that's the way that they had always done it. All right, so now we're going to ask you to give it a try. So on the slide, we've got your 7 elements of waste. So I'd like you to stop the video and right, think about where have you seen examples of these wastes, either in your process or all right, another process that you've observed, and try to come up with 1 or 2 for each one of the elements. Right, the real test is going to be to go do it on your process as you work your particular project. But take a few minutes and see if you can come up with some examples of each one of these wastes. So hopefully you came up with some good examples for some of the 7 elements of waste. And now we're going to look at a system that goes kind of hand in hand with the 7 elements of waste to make it more obvious that one of the wastes is present, and that's called 5S or 5S workplace organization. All right. So what are the 5 S's? And we've got them listed for you here. Sort of the Japanese equivalent, even the little Japanese way to spell the word. But it is a process designed to organize your workplace. So sometimes we call it just workplace organization. Keep it neat and clean to a standardized condition, and having the discipline to keep it that way. So it really works nicely together with the again the 7 elements of waste. So we have Siri, put things in order. Seitan, right, arrange things for use. Seiso, or clean. Seiketsu, or purity. And Shitsuke, or commitment to the other 4 S's. So let's take a look at right, each one and some examples of each. All right, so step 1, Siri or sort, and I apologize if I've really messed up the Japanese pronunciation, but we use the 5S English version. We're going to sort. So basically, we go to the work area and we start to dissect it. So we look for, hey, what do we really need to perform the operation? And then what stuff is laying around here that we don't really need, that's just kind of gumming up the works. And typically we use what we call a little red tag exercise. You can use sticky notes, but there's, actually sell little red tags that you can place on things. And so it's kind of fun. We go out there and we start to tape these red tags or tie these red tags onto the unneeded items. All right. So just to make sure that we don't overdo it, typically we move the red tagged items to a little holding area for some short period of time. This must be created. So whether we take over a conference room or we take over part of the incoming or outgoing material space, we're just going to keep it there just in case we need it. We need to bring it back into the area. And then, some things we can dispose of, but eventually every tagged item we're going to make a decision. Either we're going to repurpose it for something else, we're going to throw it away, or we might scrap it and get some residual value from it. So this is a lot of fun. We're going to go out and really attack the workspace and just look for things that we actually need to perform the work at that step, and we're going to get rid of everything else that's not needed. So now we've gotten rid of all of the unnecessary items. So now everything that's left at the workstation we say we need. And so the second step is Satan or store and straighten. And I like to call this step, right, a place for everything and everything in its place. So if we need it there at the workstation, let's find a good place for it. So we're going to determine the location and also determine how much should we have at the station. And we're going to make it very obvious. So we tape the areas where things belong, right? We can use some type of borders or boundaries. We can paint lines on the floor. I really like the shadow boards where, right, if you think about it as a dead man outline. If we need a screwdriver, it's very obvious this is the screwdriver and that's where it belongs. If we need a crescent wrench, right, that's the space where the crescent wrench goes, and it's either there or it's not there, right? And if it's not there, it should be used, on the station. And then it also becomes very obvious that if it goes missing, that we need to, right, replace it and keep the station whole. Right, so we're going to document that whole layout. Right, where does equipment go? Right, think ergonomics. Where's the right place? Where are the most used things? Maybe we move out a little bit for the lesser used things. Safety in mind, right? If we have things that are things like robots and things that are moving, right? We have keep out areas and lockouts so that right, we can keep everybody safe. And then right, labeling, right, any supplies that we use. Right, I've got my workbench and I've got everything all laid out in a nice and orderly fashion. At the next step, shine it up, right? Make it nice and clean. So it really does literally mean, hey, let's go scrub everything and make sure that it's ready for action. So let's get rid of all the dirt, grime, and the dust. I can tell you I've been to quite a few manufacturing plants where there are pallets just laying in the floor. Some of the cooling fluid for the cutting blades is just kind of running down. So you can't really tell if there's a problem, there's not a problem, there's just stuff everywhere. So the idea of shine is to, right, reinforce the last step, which is, right, every place for everything, everything in its place. If the workplace isn't clean and we can't tell whether or not, right, it's organized. All right, so this one starts off into the next phase, which is some discipline too, is, right, we want to actually make a plan for how we're going to keep the station that way. So what are the, as crazy as it sounds, what are the cleaning materials that I need? Where will they be stored? We actually put together a little schedule that right on these days, these individuals are going to, right, do these particular tasks to keep things nice and shiny. So, right, literally, we're going to, right, clean everything up, make it look good, and again, it reinforces both the upstream and the downstream steps in the 5S. Right. The next step is to standardize. So across, right, your production area, you want to use the same visual cues. So if I paint red lines on the floor, and that means keep out, that should be the case right throughout the whole building. So the things I use to organize and to give myself cues that we are either in control or out of control, right, I want to be the same. And then for the workplace that you're making better, right, whatever we need to document in terms of, hey, take a picture, right? This is what it should look like, right, if we've done our proper storing and straightening. make it as visual as possible. We'll talk more about that. And then what does cleaning and shine, right, actually mean? So, right, we'll talk about the control phase for DMAIC. This is sort of the right control phase for 5S, that we have a standard way to do it, and we're doing it consistently from workstation to workstation, production line to production line. Right, so the last step in the 5S's is sort of an audit function. Let's make sure we're doing the 4 steps. You can make this a lot of fun, or a competition. One group can audit another group. You can determine what the frequency should be, but basically, right, are we performing to the standards? We talked about right, a place for everything and everything in its place. If I go and inspect a workstation, right, am I conforming to that? And then the cleaning part. So do I see a cleaning schedule? Right, is it being executed? Right, will we mark off that we've completed it for that day or that week? So you can make it kind of fun. Look at right, who gets the best audit scores from one place to the next. So little exercise for you, so you can pause the recording here in a second. How might you apply 5S to well, hopefully to your workstation. But think about right. I think about this in my garage. Whenever I go out there, I can't find the right screwdriver. Right, the crescent wrench I need is gone. Where are the bits for my drill? So I'm sure many of you feel the same pain. Right, if you're a baker or a good cook, right, all your pots and pans and your spices and everything ready to roll. Sometimes doing 5S on areas that your spouse may also occupy are you got to be careful. I did it with our drug cabinet, right, based on right, what do we really need and what do we not need. So I went through and I looked for the things that we took on a daily basis, and I put those down on the shelf you could see, and I put them in order. And then all the things that we just accumulated over time, right, I put them in a bag and right, put them on the top shelf, way out of reach. And then when my spouse got home, she told me that she didn't really like that, and she wanted me to put it back the way that it was. And then I put it back the way that it was, and then she said, that really was a good idea. Let's do that 5S thing, and right, make sure that we have the medications that we need daily right there, front and center. So take a few minutes, stop the recording. Think about how you would approach the first 3 steps of right, sort, straighten, and shine in one of these 3 scenarios. So now we have made you armed and dangerous with the tools of the 7 elements of waste and the 5 steps and 5S process. All right, and right, that supports the body of knowledge elements. We talked a little bit about what's the philosophy of lean, right? How did it come to us through the Toyota production system, right, into now the 21st century? How the tools for Lean and Six Sigma work together, and then specifically the tools of how do we identify and segregate waste, and that 5S process itself. All right, very nicely, we have come to the end of the define phase. So 20% of the knowledge and tools and tasks in order to execute and conduct a good Lean Six Sigma project. So let's do some wrap up and talk about some actions, and then we'll get into the measure phase. All right, so back to our high-level map. We've got our 5 phases, and like I just said, right where we're got 20% of the way there, we've looked at the project charter. We get our resources, our team put together, and we've done a quick look at what are the savings we can bring to the business through cost of poor quality savings. Here we have the more detailed flowchart for the define phase. So we talked about, we start with the business imperative. Why would we want to do an improvement effort, and where would that improvement effort focus? In the example we ran through, that we want to lower material costs. And then we looked at the tree diagram and how we went across and figured out that, hey, the first project we're going to work on is punch press scrap. And we went through many levels in order to get there. Once we decide on the effort, a belt like yourself would be assigned as the lead. All right, some of the other activities we can kind of do in different orders, but who are the stakeholders, so that we can make sure that all of leadership, anyone that can say no, is in back of the effort, again, pointing back to the business case of why we need to fix the process in order to fix the output. We talked about chartering and all the elements of a good charter, your team, a timeline, the objective statement, restating the business case as the problem statement. Then I've got two boxes here of scoping. So looking at sort of the horizontal boundaries, which would again come from your tree diagram. Are we going to work on all products, one product, right? In the case of the material costs, well, I could look at all scrap, but hey, we decided that let's start with the scrap produced on this particular production line on this particular machine. And then we talked about using a high-level process map as the vertical boundaries of the process improvement that I'm going to do. What's the first step and what's the last step? And I'm going to focus on everything in between. And then we can adjust those boundaries as we need to, if we find that we need to go upstream or downstream to solve the problem. Finally, we're going to estimate the value to the business. What costs of poor quality are we going to eliminate? And we then have a formal approval. Is the charter approved or not? Right, if yes, we're going to assemble the team and launch, and then we're ready for the measure phase. If we find out maybe there's really no value, we can't decide on the scope, stakeholders don't think it's the right thing to work on. So if we fail at any of these steps, we might go back and, okay, let's pick out a different business case and bring that one forward. So at the end, we are now ready to launch the project with our team, and we will move in the next sections into tools of the measure phase. All right, so here are a few of what I think are some good goals for the define phase. Right, we're going to identify what is the process that we're going to improve. So again, we're using your business case, tree diagrams. What is the very specific high-level piece of the flow that we're going to go after? Right, we kind of put a contract together through the use of the charter that says exactly who's going to work on, lead the effort, who's going to sponsor the effort, and what we think the original timeline and cost benefit are as defined in that charter. Right? And then at the completion of the define phase, we've got a good description of the process, why, the thing that we're going to fix, right, that's creating the waste in the business. So if we can really answer those 3 bullet points, and I've got some more checklists coming up, we've done a good job completing the define phase. Here's an action item list you can use to plan and execute the define activities. We're going to do some business case development. We're going to develop a high-level process flow. We're going to put together the charter that has all these elements, and then we're going to look at what the return on investment. So if I fix the item that we have defined in the objective, what will the impact be to, right, the customer, the business, or the employee, right, our 3 voices. Right, so the people side of the equation, how do we get there? Change is not simple task. We're trying to convince people to stop a current behavior and change to a different behavior using a data driven approach. So it requires you as the team lead to right, take some risk, be tenacious, be courageous. You've got the competencies as a result of this course to use that data driven approach. Do be disciplined to follow the process. There's always the temptation to skip steps, to move ahead, to just fix it. We do want to make sure that we are really addressing root causes and that we've used the formality of the DMAIC process to get to that point. Right, you yourself are going to have to embrace change and learning, and hopefully your teammates, your sponsor, and right, the others that you touch in the course of doing the project will do so as well. The good news is you then become also sort of an instructor or teacher for the organization. So we showed you so far how to do a Pareto chart. Your teammates probably don't know what that is. And so when we put one together, and you're going to show it in a team meeting, you'll have to go in and describe and bring everybody's competency up to the tools that we're going to use to make decisions. And then in the end, hey, what works, what doesn't work, sharing amongst your peers of the best way to navigate through the process in your particular situation. So again, based on many decades of experience, what types of roadblocks might you run into in the define phase? Right, the first and the last bullet are linked. Hey, really nail the project charter. Have a good problem statement, a good objective, a good timeline. Pick out some good subject matter experts. That's really the big key to success. Right, goes without saying that we're linked to some business imperative, so I should be able to talk about the voice of the customer, voice of the business, voice of the employee, imperatives that are linked to fixing the objective in my charter. A big one out of the gate, if you set up your first team meetings and you get rather marginal attendance, it's time to go to write the sponsor and say, hey, if this is important, I need my experts to help me. So that checks for the commitment in order to make the project happen. So definitely that should be an early warning sign that you need better backing. Avoid the trap, again, back to the scope and the charter. You'll get a lot of opinions of people. Oh, I know how to fix that, right? Just go and do that. Well, that's not data. And it's going to take a while to get the disciplined approach to not jump to the improve phase, right? And scope, scope, scope. Avoid scope creep at all costs, unless we're willing to take a step back and look at the charter and go, okay, if we're going to rescope it in this fashion, then this is how we have to reshape the activities, and these are the resources we need to do that. All right, so a more detailed checklist than the one we showed a few slides ago. Just some sort of thought starters. Hey, did you at least think about this? In all of the materials we're going to show you, we're giving you the most generic, well-tuned path through the DMAIC process. Now, do you have to use every single graph chart in every single project? Probably not. My advice in the beginning is always err on the side of doing a little bit extra. What I always say is, with the tools we have today, if you make a chart or a graph and it you don't end up using it in your final presentation, big deal. It took 5 or 10 minutes to put it together with all the technology that we have. So you always, you can use this as just a primer to your Tollgate review. If you can answer these questions, then you've done a good solid job of completing everything you need to in the define phase. All right, so we're ready to move out of define phase and into measure. So we've got a little project plan put together. Again, DMAIC naturally puts itself into sort of project management 101. I've got 5 phases, 5 milestones. I can put timing to the entry and exit of each one of those phases, or I can work backwards. When do I need to have my solutions in place, and right back into what the dates need to be in order to get there. Right, we should have addressed any potential roadblocks with our sponsor and stakeholders. We don't want these to continue to build and pull the project back from moving forward. All right, and hey, step and repeat. Well, hopefully you'll do lots of defined phases and charters as you move forward in your career. Just a little extra here. The training material that we have for you here is laid out to support the agreed upon body of knowledge for what a black belt should know. And so these are all the elements that are included in and line up with the defined phase. You can probably remember now touching on these different topics. If you want to ever review any of these, you can go to the chapter that they're in, and even you could fast forward to that specific element in the training module.